Have you ever wondered why all planets are perfectly round? And what if these celestial bodies decided to break the rules and change their shape? Would we end up with square planets, triangular moons, or maybe even intergalactic shapes we can't even imagine? Well, let's find out. So how do planets form in the first place? The universe is filled with swirling clouds of dust and gas. These clouds, called molecular clouds, consist of various elements and compounds, such as hydrogen, helium, carbon, oxygen, and so on. They're like a cosmic kitchen filled with the ingredients needed to cook up some brand new planets. The first step in the recipe for planetary formation is called the accretion theory. Let's say that something happens that causes gravitational instability, like a supernova goes off nearby or something. This pushes the gas and dust in the cloud and causes them to come together. Because of gravity, these particles start falling toward a central point. They become more tightly packed together, like when you squeeze a ball in your hand. And eventually, they're squeezed so hard that the cloud starts to flatten into a disc shape. Kind of like when you mix flour and water to make pizza dough. This disk is called a protoplanetary disk. It's also spinning because the cloud's particles had some rotation to begin with. Now, imagine these tiny dust particles and gas molecules dancing around in the disk. Sometimes they bump into each other, and when they do, they stick together like Velcro. These little clumps of dust and gas are called planetesimals. They're the building blocks of planets. And as the planetesimals continued to collide and merge, they grew larger and larger, forming protoplanets. The protoplanets were getting serious about their size, and their gravity became stronger. Some of them got so massive that they became the grand masters of their cosmic neighborhoods, the planets we know and love. Each planet had its own unique recipe of gases, rocks, and sometimes even water. But why do the planets look like spheres? Well, it's all because of gravity. Let's go back to our protoplanets. Imagine you're squeezing a balloon with your hands. The air inside of the balloon pushes back, creating pressure. Something similar happens with planets. Gravity squeezes its material inward, pulling in towards the center. And since gravity acts equally in all directions, it pulls material from all sides toward the center of mass, resulting in a sphere-like shape. And that material pushes back with pressure, resisting the force of gravity. In the end, they both find a sweet spot where they balance each other out. It's called hydrostatic equilibrium, a fancy term that means everything inside a planet is in balance. But that's not all. Another thing that makes the planet spherical is their rotation. Think about a ball of Play-Doh or something like that. Imagine you spin it rapidly. The material starts to push outward, making the Play-Doh bulge at the equator and flatten at the poles. The same thing happens to planets. As they spin on their axes, the combination of gravity and rotation pushes the material outward, making the planet bulge at the equator. They low-key want to become disks again. However, gravity doesn't want any lumpy planets. It wants them to be nice and round, so it keeps pulling on the material, trying to make everything as compact as possible. Eventually, gravity wins, and the planet settles into a spherical shape. Let's take some examples from our planetary playlist. Jupiter, the giant of the solar system, loves to show off its oblateness. It spins so fast that it becomes noticeably squished at the poles and chubby in the middle. It's like a spinning top with a cute belly. Saturn, the ringed wonder, also joins the oblate party. It spins around with its beautiful rings, and its oblateness is even more pronounced than Jupiter's. These examples show how rotation can give planets a unique shape. They go from being perfectly round to having a delightful bulge around the middle. It's like cosmic pottery, where the spinning motion creates a playful and distinct shape. So now you know why the planets are round. But what's more interesting is, what if they weren't? What if they were, let's say, cubical, or even triangular? Well, let's see. A cube-shaped or a triangle-shaped planet would have its mass spread out in a completely different way than a sphere. And you know what that means? Gravity would be all shook up too. On a spherical planet, gravity pulls everything towards the center because the mass is evenly distributed around that center. But when we introduce a cube-shaped or triangle-shaped planet, things get interesting. If you're standing at the center of one of those faces, you'd feel the strongest pull of gravity. That's because the faces are the closest to the center of gravity. And as you venture away from the center and start walking towards the edges, gravity starts playing tricks on you. You would feel the struggle against the steep-angled gravity. Walking on those edges would feel just like climbing a mountain, or walking on a super steep slope. All because gravity wants you right in the middle of the face, and nowhere else. Now imagine the terrain along the edges and corners. It's a barren, rocky, and dry landscape. Why? Well, all the water would pool in at the center of each face, leaving the edges high and dry. And the air quality? Well, it's either non-existent or so thin that it can't support life. Not the coziest place to set up camp, that's for sure. And don't forget your warm clothes, lunch, and hiking boots. You'll need them because of the crazy climate. The type of climate you'll encounter on our cube or triangle-shaped Earth depends on how it spins. If it rotates at its corners, each side would enjoy a mild, temperate climate. However, if it rotates on an axis through two of its faces, things get intense. Picture a roller coaster version of our current climate. Some faces would be polar wonderlands, icy and chilly. The top and bottom faces for the cube, and the bottom face for the triangle. Meanwhile, the other sides would be completely different. In a cube, they would be scorching hot with an equatorial climate that would make you break a sweat. Instead of sunlight gently curving along the surface, it would directly beam onto these faces. Talk about feeling the heat. And on a triangular planet, the sunlight would strike the faces at an angle. This angled sunlight would create fascinating temperature variations across the planet. Imagine this. As you move from the base of the triangle towards the tip, the temperatures would gradually decrease. The base, where the sunlight hits most directly, would be the hottest region, just like the equatorial climate we're familiar with on our spherical Earth. But as you venture towards the tip, the angle of sunlight would be less direct, leading to cooler temperatures. But the base is still super cold and dark, since the sunlight doesn't directly reach it. So the triangle would be absolutely crazy in terms of temperature changes and climate zones. By the way, you know that cozy blanket of air we call the atmosphere? Well, on our angular Earth, things would get a little topsy-turvy. Gravity would be pulling stronger from the center of each face. The result? The atmosphere would go through some crazy changes. Picture this. At the center of each face, where gravity is strongest, the atmosphere would gather and thicken. It would be like a bustling city, full of air molecules. But as you venture towards the edges, things would start to thin out. The atmosphere would become scarce and very thin. So breathing along the edges would be quite a challenge, and the edges would be a tough neighborhood for life to thrive. Moreover, a thinner atmosphere means less protection from the sun's radiation and solar winds, so corners and edges would be extremely dangerous for humans. Of course, this is all just a playful exploration of what could be. Our Earth loves its spherical shape, and that's a good thing. But there's no harm in imagining wild and wonderful possibilities, so keep your imagination soaring and continue to marvel at the marvels of our amazing planet, however it may be shaped.
Okay, what if pressing only one key could change your life forever and make it much easier? Well, if we were in Minecraft, everything would be possible. Too hard to live? Too many tasks, deadline, school classes are tedious, and you just can't go on like this? Change your life mode to somewhat less challenging. Just press escape. Adjust your life difficulty choosing peaceful, easy, normal, or even hard for those who like it tough. If your teacher is as hostile as a green and white pixelated creeper, choose peaceful mode. Monsters don't spawn there. Or just get yourself a cat. Creepers are terrified when they see them. Even if your pet looks a bit boxish. One more cool piece of news, if your life is in peaceful mode now, you don't even need to eat, which could save you a ton of money. As for appearances, no more worries about pimples. Now that you're pixelated, nobody's ever going to notice them. You look the same every day. Your haircut, even if you hate it and can't wait for your hair to grow, never changes unless you change the skins. You can't grow or lose some pounds. Your body proportions are much different too. In our world, the head-to-body ratio is about 1:7, and in Minecraft, it's more as if everyone had a baby body with a huge head and smaller torso. You wouldn't have fingers, so if you had Minecraft body in real life, you wouldn't be good at fine motor skills. I guess no Minecraft surgery, huh? No matter what kind of biome you live in, you don't need some super cold-resistant clothes or nice shoes. Life without changes means that you don't age the way we normally do. No more birthdays anymore. The cake you find in the game is not for candles or making wishes. It can only help you if you're starving. A day-night cycle is somewhat different now, with 100 Minecraft days equaling 33 standard hours, so life expectancy should change too. The average lifespan in the USA is 78 years, or about 683,000 hours. So the average lifespan, according to Minecraft, would jump up to 5,700 years. Hey, and you can also respawn. Ready to live forever? Food isn't that different from what we have in real life, even in terms of calories. A whole cake will replenish your energy so much more than a plain beetroot. Carbs. There would be some exceptions too. A golden apple gives extra health in Minecraft. So sad golden delicious from Walmart are only delicious in real life. You can starve in Minecraft in 2 game days, though it takes a bit longer in real life. Yeah, going with no food is a real challenge, but a human actually can do that. Water, on the other hand, is pretty essential in our world, but doesn't do much to Minecraft people when they drink it. Today's agriculture uses some fertilizers to speed up plant growing. But if we had that bone meal Minecraft people feed their plants with, we'd have an abundance of any fruit or vegetables. Life would be quite boring though. You wake up today and you mine. You wake up the next day, you craft. The retail industry could never compete with skillful people, who actually don't need it, being able to create various objects from scratch. Anyway, you don't need that much. You can do almost anything with a mere pickaxe, upgrading it to a diamond one. All those hardware stores full of handy items would go bust in a real world with a pickaxe replacing everything else. You'd also have to be a bit more hard-working though. If you want to have a nap, there's no way you can do that in the Minecraft world. Here, you only sleep at night or if there's bad weather outside. Sleep is essential not to be caught by monsters that appear as soon as the night falls. And you gotta be sure there are no monsters nearby before you go to bed anyway. You can only sleep in your bed though. Even if you want to spread on a nice meadow in the shadow, you won't just fall asleep. Same with school classes. No matter how boring they are, it's just impossible to doze off. If you're used to watching pop science TV shows, well, that's something that would probably be almost unchanged. Discovery Channel would show not only various biomes and square animals, but other worlds too, like the Nether and the Overworld. Anyway, you wouldn't spend that much time indoors. Most activities in Minecraft are performed outdoors, so you'd have to go outside really often. Traveling is fun in Minecraft world. Want to visit the Nether? No, not the Netherlands. It's a trip to the underworld. No need to buy tickets, go through customs, spend hours in a tiny airplane seat. You only want some lava and a bit of water. Pour one over the other and you get obsidian. As soon as you create at least 8 blocks of the stuff, build a portal with them, set it on fire, and voila! Welcome to the Nether. If you travel a lot, you can casually grab your bed with you and assemble it wherever you want. Nice move to avoid pricey hotels, which are missing in the Nether anyway. It's not just a fun trip though. There are a bunch of ingredients you may need for potions. No fancy souvenirs either. Rather, some useful stuff you mine from exotic Nether blocks. Despite their moniker, locals called zombie pigmen are quite friendly and never attack unless it's you who started a fight. Lava can help you to travel, be a kind of trash bin, and keep intruders away. In Minecraft world, you can be sure unexpected guests won't bother you. They'll just fall into boiling lava. End of story. You can also install a tripwire hook just behind your front door to activate piston-based traps for unwanted visitors. Once your guest triggers the tripwire, the pistons will remove the flooring and send the visitor into the void. If you're going to the seaside, take your front door with you. It'll help you explore the ocean deep. If you fall into water, all you need to breathe freely is place a door above you. Nobody could ever hold their breath for more than 24 minutes in our real life, but in Minecraft, you can stay underwater almost forever, or just as long as you want. Transportation system is much cooler now. You can still use all the means of transport you're used to, but having a ride in a cart can be both fun and fast. Just build the rails wherever you want and forget about traffic jams. Physics are another big change. They give you lots of superpowers not accessible in the real world. You can jump higher, climb any mountain easier, and run faster as if the whole gravity stuff was a joke to you. You can make a vertical row of blocks, and even if you smash the lowest block, the one above it will hang in the air. It doesn't mean you can't fall down from a height. You can. But it's safe if you just spill some water from a bucket right before the impact. Not only can you perform all of that, but you can also easily chop a massive trunk in just a few moves. No tools necessary, by the way, just your bare hands. And not even a scratch left on them afterwards. You don't feel pain in this world. Don't worry, the top branches of the tree you just fell won't hurt you either, since they'll be hung in the air. Deforestation in Minecraft looks insane. Can you imagine a forest made up of floating trees? No squirrel could ever climb any trunk in such a forest. Walking around here, you're likely to come across wild animals, such as bears and wolves. You can domesticate wolves and almost convert them into dogs, and bears are not that dangerous for you. Just trap them inside a fence. It looks flimsy, but it's Minecraft world, so it's absolutely safe.
Now, Jupiter used to be flat and look like an M&M candy. Now I'm hungry. And it wasn't the only flat pattern in our solar system. Turns out, there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed into open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun. And when it was just a baby planet, it likely formed through a process called disk instability. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disks helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust, smaller than a human hair. Eventually, they formed their own big ring-shaped disks of gas. They began to spin around our Sun, growing bigger by gathering gas and rocks like snowballs. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets, like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our Sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. Recently, simulations showed that these protoplanets, as these early dust balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they look more like squashed balls or M&M's candies, not the peanut kind. When the Sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin in the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they all twirl in the same way. So, theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the Sun and nearby planets pulled them back into place. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star, while the other side remains in perpetual darkness. So, one side is always very hot, while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of work like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. We've discovered more than 5,000 planets outside of our solar system called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits, or so-called hot Jupiters. They're super close to their star, way closer than Mercury is to our Sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. There are three main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the Sun billions of years ago. I wasn't around then. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them. There might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm, even though they're far from any star. Some of them might have wild auroras, while others could host moons with liquid water, a potential haven for life. There's even a chance that they might contain extraterrestrial life. These planets might bump into other stars or even entire planetary systems as they journey through space. Sometimes they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and two planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. This is unusual because planets usually form from clouds of gas that contain heavier stuff. That's when we figured out that the way planets formed before was different from how they form now. We know that stars with more metals are more likely to have planets. In astronomy lingo, metals means any chemical element other than hydrogen and helium. But in the early universe, there weren't many metals. Most of them were created inside stars and then spread out into space when those stars blew up. So, when did the very first planets form? This newly discovered system helps answer these questions. Its two giant planets are orbiting a star that's incredibly low in metals and extremely old. This should be really rare, if not impossible, but they exist. This means that maybe there are more planets in metal-poor systems than we thought. Studying them will help us learn more about the history of planet formation.
Check out that buff dude over there with the orange skin. He's been chilling on Mars for a hot minute, which is why he looks like he used the wrong shade of self-tan. You see, all those carotenoids in carrots, sweet potatoes, bell peppers, tomatoes, and pumpkins are protecting him from those UV rays. The more he eats, the more orange he gets. And as for his sturdiness, it's all about that Martian gravity. The gravity here makes us perceive our weight differently, and if you want to be a boss on Mars, you gotta eat heavily. Like, if a person weighs 150 pounds on Earth, it feels like no more than 55 pounds on Mars. So, overeating can help shorten that gravity-to-weight gap. Mercury is a whole different thing. It's hotter than Georgia asphalt during the day, but colder than Elsa's castle at night. You gotta be made of metal, with a high melting point to be able to survive here. But for us regular humans, we'd be toast. Literally. Even though Mercury is the closest planet to the Sun, Venus is still the hottest one. Life on Venus? More like life on the Sun's evil twin. The temperature here typically hovers around 870 degrees Fahrenheit on average. Surviving at the boiling point of water, or in the extreme heat of Venus, is a challenge for most earthly species. Only a select few can endure boiling hot temperatures. Others rush to Starbucks to grab an iced latte with the first beams of the spring sun. So no human being can really evolve enough to survive on Venus. The only creatures that could thrive there are probably tardigrades and those weirdos who put hot sauce on everything. You wonder what tardigrades are? Well, those are minuscule and adorable caterpillar-like creatures that possess remarkable durability. They can endure boiling water, the depths of a sea trench, and the frigid, lightless void of space. Recently, tardigrades were included in a scientific study aboard a spacecraft that unfortunately crashed on the moon. Scientists speculate that the tardigrades may have survived the impact. Hey, would you like to turn into this creature and live on Venus? We're done with terrestrial planets. Let's move on to gas giants. Now look at this dude from Saturn. He's got flippers and not arms. He's got small holes with no external ear flaps instead of regular ears. Most of this gas giant is colder than your ex's heart, as the temperature is about minus 220 F. You can't walk on it, but you can turn into a snowball or an ice crystal if you're feeling frisky. Things are quite similar on Jupiter, so probably turning into a seal and chilling there is not that bad of an idea. At least you can live there rent-free. And don't even get me started on Neptune and Uranus. These guys are ice giants with no solid surface, so those sharp-clawed dudes you see in movies? Yeah, they don't exist. Plus, these two ain't exactly hospitable to life. I'll stick to my sweet potatoes on Mars. Thank you very much.
We all remember seeing the Apollo lunar rover on the moon built for space missions in the 70s. Besides transporting astronauts for certain explorations, they were used for taking pictures and collecting soil samples for scientists to study. The vehicle was designed by Boeing, the company famous for building airplanes, and cost around $38 million to build. The kind of loose change you'd find today in Elon Musk's couch. In the far future, technologies will be so advanced that a regular car for the moon will behave like a regular SUV we have today. It'll have a sleek look and might be produced by some famous car manufacturers available. Back then, the lunar rover used a T-shaped throttle to move the car left, right, backward, and forward. The futuristic one can be voice-controlled and require minimal human control. And we can't leave out the Earth roof. Hey, you really don't need a moon roof on the moon. Anyway, the moon's driving conditions are not that extreme compared to Mars or other planets. It's hard to believe that the first landing craft to enter Mars was Viking 1, launched on August 20, 1975. It arrived at Mars on June 19, 1976. But decades later, Curiosity, which had 6 legs and 6 wheels attached, took the stage as the cute robot explorer. It was designed for the rough terrain, so in the distant future, a human-operated vehicle can have a similar design for people who want to cruise by the Mars sunset. For any human-designed car to work on planets other than the Earth, They have to be electric or anything else that can produce an unlimited supply of energy. Gas-powered vehicles won't work in the vacuum of space, and certainly not on any planet other than our own. It can be powered by the strong sun and convert the energy to run the vehicle. The interior has to accommodate the extreme conditions on the planet, since the atmosphere is very thin and unbreathable. It has to be very warm, since Mars can reach sub-zero temperatures. The matter of gravity isn't that extreme, but frequent dust storms are the problem. The vehicle will also have wheels attached to legs to maneuver around properly, since the terrain is difficult to get around in. Now, my 2 cents here? Well, I think an all-leather interior with 6-way seats front and back will be nice. Adding a 12-speaker sound system with Are You Serious FM radio is a must. Did I mention the earth roof? Yeah, I did. And don't forget the 60/40 fold-down rear seats so you'll have plenty of room to haul your camping gear on your weekend escapes. Meanwhile, it's still possible to have a panoramic glass view of the interior in a project like a tour bus on Mars. There are plenty of locations to discover, like the tallest mountain in our solar system and the snowy Carbon Peaks. The Red Planet can also have an express train ride that can take you from one place to another. It'll be one of those luxurious cabins that will take you from one landmark to another since Mars becomes colonized and established. The train will also be electric-powered or powered by another power source. Mars is a place where it's possible to have all kinds of vehicles, since the conditions aren't that different from Earth's. Just don't go outside without a helmet. If we designed a vehicle for Mercury, then get ready for bright light from the sun, in which case we would need to add industrial visors and blackout strips around the glass so that the sun won't get to us. At least we won't have to worry about the heat, since Mercury isn't the hottest planet in our solar system. Well, the temperatures can reach a soaring 800 degrees on a warm sunny day and drop down to minus 300 degrees at night. The vehicle will have to have multiple layers and coatings to withstand the conditions, and it will most likely have spider legs to move, since rubber wheels will melt instantly. And to save itself from damage, it'll need to dig underground to hide from the sun and atmosphere, just like a crab or those spiders that create hatch floors. Driving a vehicle on Pluto will be very challenging, considering that it's the furthest planet from the Sun. Now, Pluto is technically not a planet anymore, but it's still a large enough mass to explore. Temperatures there can reach below 400 degrees. A mere jacket won't cut it. The vehicle will need super insulation to keep the operator warm and fuzzy. Methane ice surrounds the land and covers the mountains. Gravity is also an issue since it's very weak, which will make you float in the air. Now, designing a vehicle for Pluto will be tricky. The key for it to move and not freeze will be how the legs move. It'll also have legs like the one on Mercury, but will have a lot of heat generated to keep warm. The weight is enough to keep this vehicle in place. However, that can't be said for Neptune, the windiest planet in our solar system. It's impossible to breathe in the atmosphere, and the atmospheric pressure will crush you. Designing a vehicle is challenging, considering the many external factors, and will have to be pressurized to counter the external atmosphere. It will also need a special coating to counter the harsh temperatures. And because Neptune is extremely windy, it would need some sort of anchor to keep it in place, something like a large drill that shoots from the belly of the car and digs underground. It will also have spider legs to move around, but they'll behave in a similar motion to how a camel walks. That way, it can maintain its center of gravity. Now, Venus is the hottest planet in our solar system, with temperatures reaching 1,000 degrees. The pressure will press your vehicle like a can, so it needs proper internal pressure to balance it out. This car will require all the upgrades for countering the heat. It will need proper coating, no glass, and even a special color to reflect the heat. Nothing can actually stay on the ground for too long, so spider legs won't really work. It'll need to hover slightly above the ground and float around. Now, Saturn is the second largest planet in our solar system and has a very windy upper atmosphere and very strong gravity. The rings around it are made up of ice materials that can range from the size of a pebble to the size of a school bus. The pressure is so strong that you'd be crushed the second you reach its atmosphere. Designing a vehicle would be very challenging and weird. It'll need the best technology for withstanding the crushing pressures and harsh temperatures. The vehicle will have to be large and composed of many internal layers. Since the upper atmosphere is windy, the vehicle will have to remain on the ground for as long as possible. Scientists don't know much of what the surface looks like, so the vehicle will have to be prepared to move on solid surfaces, liquid, and anything else in between. Now, I think it's called slop. It'll need mechanical arms to maneuver through the possible rugged terrain and multiple legs like a centipede. Those arms can pick up things and move them out of the way if it faces some obstacles. The long body can also detach itself and break into smaller pods for a quick escape. From what, we don't yet know. No human can step foot outside even if they wear protective gear. Robots will have to be deployed to test how human bodies can withstand the conditions. Jupiter has harsher conditions than Saturn, with the red spot being the most dangerous area on the planet. It's an extremely large area that has hurricane-like storms that have been going on for years. The vehicle will resemble that of Saturn, but extra heavy-duty. Scientists also don't know what's happening on the surface except for the crushing atmospheric pressure. The vehicle won't be able to move on the surface if it were to pass through the red spot, so it'll have to dig underground and move underneath. For that, it'll require a huge drill and many self-automated drones and vehicles that can be deployed from the main vehicle to help with digging and surveying. Once underground, it'll have legs that will help it crawl and a giant drill nose to dig further. Many of the body parts can also break off into smaller pods to get through certain terrains, but can be easily reattached. The craziest place where we can launch a vehicle is the Sun. There's no way to imagine it except being self-automated. Any human on board won't make it halfway in the journey. The launch will have to be from Mercury in a protective facility sheltered from the harsh temperatures. The vehicle will have to be made out of the best resources to withstand the extreme heat and gases, and won't last more than a couple of minutes once nearby. It'll most likely resemble a satellite and float around to take some footage for us to study. It'll probably cost trillions of dollars, but the results will be worth it, won't they?
The infinite vasts of the universe hold endless possibilities and secrets. And here's one of the intriguing questions: how life and we as humans would look like on other planets. Imagine a world where the laws of physics, the environment, and the conditions are vastly different from what we're used to. How would we adapt and evolve to survive in these strange new lands? Let's see. Mercury is the closest planet to the Sun and has a thin atmosphere. The temperatures there are extreme, with the day side reaching over 800 degrees Fahrenheit and the night side dropping to negative 290 degrees Fahrenheit. So, what can we do to survive these crazy temperatures and constant solar radiation? Maybe we can magically turn into metal. For example, titanium and platinum can perfectly tolerate high temperatures. But seriously though, there is an option. We could settle underground, where the temperatures aren't so frenzied. If we lived underground, we might evolve with large eyes to better capture light. We might also evolve thicker skin to protect ourselves from the intense radiation. Basically, we have two options: become metal or become moles. Let's move on to Venus. This planet is extremely hostile. First of all, Venus is known for its thick, more toxic than your ex type of atmosphere. The whole planet is covered with carbon dioxide, and its surface is absolutely dry, making it incredibly hot. The average temperature is around 847 degrees Fahrenheit, making it one of the hottest planets in our solar system. Also, don't forget about the crazy pressure. Standing on Venus would be like standing 3,000 feet underwater. Only particular hardy microbes from Earth could survive in such conditions. So, if you want to live on Venus, you might have to become a microbe. But unfortunately, since we're not microbes, we have to wear special gear and equipment to survive there. Maybe we'd have to develop a heat-resistant exoskeleton to protect ourselves, as well as get some new lungs that can filter out the toxic elements in the atmosphere. Let's talk about our favorite red sibling, Mars. The first noticeable change after a few hundred years would be your new skeleton. The gravity on Mars is much weaker than on Earth, so your muscles and bones would shrink. To make up for this difference, you'd have to eat more and probably start going to the gym. Also, you'd have to adapt to the low atmospheric pressure and colder temperatures. You need to retain heat, right? That means you'd need a thicker layer of body fat. Sorry folks, but on Mars, we might become fatter. Another reason to start working out. Another big change would occur in your skin. Your skin is like a big barrier that protects you from harmful things such as bacteria, UV light, looking totally creepy, and so on. So what would happen to it? Most likely, you would turn orange, due to the carotenoids. Carotenoids are a type of nutrient that you get from foods such as carrots, potatoes, tomatoes, and so on. They protect very well against ultraviolet radiation on Mars. They only have one downside. By eating a lot of pumpkins from the Martian farmer's market, you'll gradually start to turn orange. But maybe it's not so bad. Maybe life on Jupiter would be easier. Yeah, no, it has no solid land. This planet is made up of hydrogen and helium and is referred to as a gas giant. You would simply float there, like in a huge cloud. And even if you managed to land and tried to walk, it would be like moving through a super thick fog. So how would we evolve there? Firstly, we might become much larger in size to withstand the immense pressures. Secondly, the temperature fluctuations on Jupiter are enormous. The surface is terrifyingly cold and the temperature rises significantly under the outer layers of the atmosphere. Thirdly, if you lived on Jupiter, there would be no verbal language. This gas giant absorbs radio waves, so even if you were speaking, no one would hear you. There would be no music either, so no parties. And what's the point then? Hey, maybe we could communicate with sign language, but that's not so simple either. Jupiter is full of wild winds and storm clouds, so it's unlikely you would be able to see anything. So even if we evolved there in some way, our lives would still not be easy. Before landing on Saturn, you would probably want to check out its iconic rings, but you wouldn't be able to do that because Saturn's rings consist of a bunch of ice particles flying in space, so it would be extremely hard to land. So let's go straight to Saturn itself. At first, it may seem that Saturn is not bad for us. Some layers of this gas giant have quite pleasant temperatures. If we dive deeper into Saturn, it gets surprisingly warm, up to 26 degrees Fahrenheit in its second layer. This is an average temperature in countries like Sweden and Canada. But unfortunately, this is only one such layer. The rest of the planet is incredibly cold, so in order to survive on Saturn, we'd have to do a lot of work. In addition to the cold, we'd have to deal with the planet's harsh environment, including its intense storms, strong winds, and radiation. To protect ourselves from these conditions, we'd need to evolve tough skin, again, find some insulation, and so on. Next planet is Uranus. Uranus has a very different environment from Earth, with much colder temperatures, a lack of a solid surface, and a much different atmosphere. It's like another Jupiter, but with blue vibes. It's not that bad though. There's even water on Uranus. The only problem is, the planet is full of ammonia, that nasty stuff we use for cleaning, so don't be surprised if you feel the gross smell. Also, it's incredibly cold out there, almost like a never-ending winter. So what would it be like to survive in such a dark and harsh environment? We'd need thicker skin, again, to cope with extreme temperatures. And again, we'd need larger eyes to see better in all this darkness. We might even have to develop a new hearing system, like that of dolphins. Wouldn't that be fun? Let's move on to Neptune. If human beings were to evolve on Neptune, they would need to adapt to its harsh conditions. Neptune, the 8th and farthest planet from our Sun, is another gas giant. The only difference is this planet may have a solid core. If we were to live on Neptune, we'd need to float or swim in its methane-rich atmosphere. We'd also need to develop gills or something like that in order to breathe. Basically, we'd turn into space reptiles or cosmic fishes. The gravity on Neptune is slightly stronger than Earth's, but strong winds make it difficult to stand in one place. To withstand the wind, we'd need to be much heavier. Once again, you need to eat a lot and pump up some muscles. Yeah, technically it's not a planet, but we still love it and can't forget it. A small, distant, and incredibly cold world. Pluto's even smaller than our moon, and because of that, there's almost no gravity there. It will be extremely difficult to stand on it. To avoid accidentally flying into outer space while playing football, we need to create a fake gravity machine. And if we don't want to feel dizzy, we need to evolve a brand new nervous system. But Pluto isn't all that bad. For example, there's liquid water under the surface, and even some icy mountains. Maybe it would be possible to survive there if we had some serious equipment, clothes, supplies, and… nah, too much hassle. Anyway, from the scorching heat of Mercury to the freezing temperatures of Neptune, each planet has a unique set of environmental challenges and opportunities for evolution. While we may never truly know what humans would look like on these other worlds, it's exciting to consider the endless possibilities. Never stop looking at the stars and asking these questions. Get your closet ready. We're moving to Mercury. Your mission is to find out what you need to wear there to feel comfortable. So, Mercury is the closest planet to the Sun in our solar system. It's pretty hot here, about 800 degrees Fahrenheit, twice as much as your kitchen oven can produce. You need a heat-reflective suit like this. It looks like foil for duck roasting. The shiny, almost mirror-like surface reflects the heat rays and keeps everything inside from getting baked. That's you. This suit is designed to get to the hearts of volcanoes on Earth and can withstand up to 1,470 degrees Fahrenheit. That's twice as much as at the equator of Mercury. Oh, and bring an oxygen tank. Otherwise, you won't be able to breathe there. And you need to strap some heavy dumbbells to your legs. Mercury is smaller than Earth, and gravity is almost 3 times weaker here. So you have to increase your weight almost 3 times to feel comfortable. It gets extremely cold there at night, so you need to stuff your thermal suit with insulation. But even that won't save you from the cold. It's 3 times colder than at the North Pole. Plus, Mercury's atmosphere doesn't protect you from solar radiation as well as Earth's. So, you need to wear thick lead plates under your suit for protection. But the best thing to do is just evacuate from this planet. The next one is Venus. Although it's called Earth's twin sister, the scenery here looks frightening. A hot desert with volcanoes and clouds so dense that you can barely see the sun. These clouds contribute to the greenhouse effect. So, Venus is the hottest planet in the solar system, 890 degrees Fahrenheit. But the usual heat-reflective suit won't help you this time. The atmospheric pressure here is 92 times higher than on the surface of the Earth. That's like diving 3,200 feet underwater. So the air on Venus will just crush you. To survive, you need an airtight suit made of titanium or other sturdy materials. On Earth, we use an atmospheric diving suit like this to withstand the intense pressure underwater. It's like a mini submarine in the shape of a human body, and it's already equipped with an oxygen tank. Yes, the air on Venus is not only unbreathable, it's also toxic. The next planet is Earth. Just look out the window and decide for yourself what to wear today, okay? Let's go to Earth's satellite, the Moon. A few people have been here already, and they were wearing pretty big spacesuits. The main thing is to bring an oxygen tank. It's contained in a backpack along with the life support system. Even though it's cold, there's no atmosphere. It's almost a vacuum, and there's no air particles to take heat from your body, so you won't freeze instantly. Your suit itself should be airtight and keep the atmospheric pressure inside. The lower the pressure, the lower the temperature the fluid can boil over. In space, fluids from your body can evaporate in seconds. You don't want that, so you should wear a spacesuit. It'll also save you from dangerous solar radiation. The Moon is defenseless against it. And the gravity here is 6 times weaker than on Earth. So you can jump 6 times higher and lift 6 times more weight. It makes sense to take a little weight with you, so you don't feel as clumsy as the first astronauts. Next up, Mars. In summer, you could walk around here in shorts and a t-shirt. The highest recorded temperature here is about 95 degrees Fahrenheit. In colder times, you'd have to wear a sweater and a warm jacket here, maybe even 2. The average temperature here is slightly colder than the coldest point on Earth. But the atmospheric pressure here is frustrating. It's 170 times less than we're used to. Take the altitude at which commercial airplanes fly on Earth. Multiply it by 3. The conditions there are very similar to those on Mars. It's cold and there's no oxygen to breathe. Without a spacesuit, you'd last 2 minutes at most on Mars. So you need an airtight spacesuit on you all the time on the surface of Mars. NASA scientists are preparing a new generation of spacesuits that will allow astronauts to climb, crawl, and bend without difficulty. You'd feel like a real athlete on the surface of Mars. The gravity there is 3 times weaker than on Earth, so you could easily lift an animal the size of a tiger there. Don't forget to put a spacesuit on it, of course. Now, let's fly through the asteroid belt further into space and arrive at Jupiter. It's the largest planet in our solar system, and it's a gas giant. That means there's no solid surface, so you can't even stand there. Although, hypothetically, you could jump into Jupiter. Then you'd keep falling all the way to the planet's core. Suppose you're standing on a platform just above the surface of the planet. The first thing you feel is the force of gravity. It's 2.5 times stronger here. You feel it pulling you down, and you can barely even jump up. So it would be nice to equip your spacesuit with an exoskeleton to support your body and help you move. Plus, it's incredibly cold. You'll feel the cold at about negative 229 degrees Fahrenheit on the surface of the clouds of the gas giant. And what makes things worse is the constant wind. It can reach speeds of up to 900 miles per hour, almost twice as fast as the speed of commercial airplanes on Earth. That kind of cold wind will instantly draw heat away from your body, so your spacesuit must be really thick and warm. But the pressure at the top of these clouds is almost the same as on Earth. Technically, you could even take off your helmet here if it weren't for the lack of oxygen and severe cold. Maybe Saturn promises better conditions. Another gas giant. The gravitational force here is almost the same as on Earth, so nothing will constrain your movements, except for a massive spacesuit. It's even colder here than on Jupiter, and the pressure here is about the same as about 15 feet underwater on Earth. So, the spacesuit not only lets you breathe and stay warm, but keeps your eardrums intact. Hey, hold on tight! You just almost got blown away by a gust of wind over 1,100 miles per hour. That's not unusual on Saturn. That kind of wind on Earth could get you from one coast of the United States to another in just 2.5 hours. The only option to warm up here is to jump down to the center of the planet. The closer you get to the core, the warmer it gets. But the pressure rises at a tremendous rate. In just a few seconds of freefall, even the toughest titanium suit will be crushed. Let's finally step onto a solid surface, Titan, Saturn's moon. It's 1.5 times the size of our moon and 80% heavier. And its surface is mostly composed of water, ice, and rock. The pressure here is a little bit higher than on Earth. You wouldn't feel any discomfort if it weren't extremely cold. Titan is 9.5 times further from the Sun than Earth, so our star can barely warm this moon. The air here is mostly nitrogen, just like on Earth. But oxygen is completely absent here, so it's impossible to breathe without a spacesuit. There may be a huge ocean beneath Titan's surface. Saturn's gravity heats up this moon's core enough to make the ice melt. Plus, it must be extremely salty, which means it can remain liquid even at very low temperatures. The next 2 planets are Uranus and Neptune. So Uranus holds the record for the coldest planet in our solar system. The temperature here is about negative 224 degrees Celsius, so bring the warmest spacesuit you have. They say if you jump to the center of Uranus, at one point the pressure becomes so high that it turns hydrogen into a crust of ice. And if you get even lower, you can see the rocky core. Neptune, in turn, holds the record for the strongest winds in the solar system. It's an ice giant, just like Uranus. So the dress code here is the usual. A super warm spacesuit, a tank of oxygen, and a heating system. So far, we don't have the kind of spacesuit that would help you survive on any of the gas giants. But if you get to the core of Neptune, it gets too hot. Its temperature is almost the same as on the surface of the Sun.
Uranus has a 22-year-long winter. On a planet like that, if it was habitable, everything would be frozen and covered in ice, white and gray desert all around. People would have to stock up on food and supplies, make extra sturdy buildings and homes, and always wear thick, warm clothes. Finally, transportation would be next to impossible. But thanks to the Sun, each planet in our solar system has unique weather, climate, and seasons. There are several reasons contributing to that. First of all, it's all about how far a planet is from the Sun. If a planet is close, like our neighbor Mercury, it gets a severe sunbath. But if it's far away, like the dwarf planet Pluto, it gets frigid even during summer. Now, think about how fast a planet spins. Planets that take their sweet time to rotate, like Mercury, have super long days and nights. That means one side gets toasty hot when the sun's out and freezing cold when it's dark. Earth is pretty balanced with its moderate spin speed. The atmosphere matters too. A thick atmosphere keeps temperatures from going wild, but if there's almost no atmosphere, things heat up and cool down immensely. The tilt of a planet's axis and the orbit shape are crucial as well. Even on Earth, places near the poles get 6 months of daylight and 6 months of night. And if a planet's path around the Sun is like an oval, it heats up and cools down more than it moves. Now, no two planets are unique. While some have these changes, others don't. Let's start with Mars, our favorite little planet and potentially our future home. It's the fourth wheel in our solar system and has a quirky way of doing seasons. Like Earth, it has 4 of them, although they're roughly twice as long as those on Earth. But this planet has an eccentric egg-shaped orbit. Because of this, its orbital speed varies more. This influences these seasons. Martian winters last about 4 Earth months. They're also much colder than on Earth. Near the poles in winter, temperatures can get down to minus 190 degrees Fahrenheit. One hemisphere grows an ice cap as winter rolls in, snatching about a quarter of the atmosphere as dry ice. Then, in spring, it gives it back. Mars also doesn't have the luxury of massive oceans like Earth to balance out its extreme temperatures. Scientists believe it might have had some of that in its early days, but now all the water is gone. With no water, Mars can hit very low temperatures in winter and hotter summer days. The grand gas giant Saturn has a slightly more tilted axis than Earth. However, despite its elliptical path and tilt, it stays consistently chilly. That's because it's way out there, far from the sun's warmth. Even though it's summer, Saturn remains distant and doesn't get too cozy. It also has a thick atmosphere. The atmosphere on a planet acts like a temperature regulator. If some part gets too hot or cold, the atmosphere gently distributes this temperature across the planet. So, while one side might catch more sunlight during its equinox, the thick air ensures things stay relatively cool. Up high in Saturn's atmosphere, though, it's a different story. Temperatures can swing from seriously chilly in summer to an almost absurd minus 312 degrees Fahrenheit in winter. Uranus is the next planet, the ice giant. With an elliptical orbit and a serious distance from the Sun, it's stuck in a perpetual deep freeze. Its thick atmosphere also keeps temperatures frosty throughout the year. Uranus has a wild tilt, 3 times bigger than Earth's. It's almost lying on its side, and is probably one of the most intense places in our solar system. During Uranus's summer, one pole gets full sun, while the other end faces the deep chill of darkness. In fact, because of its weird tilt and rotation, Uranus is even colder than its more distant neighbor Neptune. As we mentioned, each season on Uranus lasts around 22 Earth years. That's as close as we get to George Martin's fantasy books. That's because Uranus takes a leisurely 84 years to complete one path around the Sun, so its journey through the year is very slow. The final planet in our solar system is Neptune. It's the most faraway icy giant. It has a tilt almost the same as Earth's and a nearly circular orbit, so it feels like it's supposed to be a bit more balanced. However, this planet maintains a bone-chilling atmosphere with unimaginably low temperatures. That's because Neptune receives only a tiny 0.1% of the sunlight Earth enjoys. On Earth, there's a gradual temperature shift from near to far. On Neptune, because of its circular orbit, there's only one atmosphere taking a spotlight. Unlike its neighbor Uranus, Neptune gets a bit of warmth from its core. But this warmth doesn't help much. The cold is pretty consistent, whether it's winter or summer. But some planets don't bother with traditional seasons. They just imitate them by having different temperature cycles throughout the year. These planets include Mercury, Venus, Mars, and Jupiter. Mercury is the closest planet to the Sun. Mercury is very weird because one full day-night cycle on that planet equals 176 Earth days. After half a year on Earth, it's finally time for Mercury people to go back home from work. That's because it moves in an egg path. This is also the reason why it has some wild temperature changes. Sometimes it's very close to the Sun, sometimes it's not. At the same time, it has no atmosphere and no protection from the Sun. This results in extremely hot days and extremely cold nights. But that means it has plenty of time to go from scorching hot to freezing cold. When it's farthest, that's Mercury's true winter, or at least how we call it. So if it had seasons, there would only be 2. The next planet is Venus. It's a planet of relentless heat. Forget about seasons. It's just plain hot there all the time. It's super close to the Sun, and its almost circular orbit and tiny tilt of 3 degrees mean temperatures stay pretty steady throughout the year. Even in the supposed winter or the middle of the night, the temperature doesn't dip below 820 degrees Fahrenheit. It also decided to have a weird spin. Venus spins in the same direction as it moves around the Sun. That means the Sun is always right overhead, pouring its entire fiery love on the planet's surface. Venus doesn't really do the seasons like Earth. The closest they have to seasons is 225 days with at least 4 hours of sunlight. This you could call Venus's version of spring and fall. Jupiter, the big guy in our solar system, doesn't bother with the whole seasons drama. It keeps things simple with a tiny tilt of 3 degrees, almost as laid back as Mercury. Plus, its orbit is a close match to a perfect circle, so it doesn't have much variation in sunlight. Also, with a speedy rotation of less than 10 Earth hours, there's no time for the appearance of seasons from long nights. Winter on Jupiter is basically a repeat of any other time of the year. And finally, Pluto, which is still not a planet, but still worth looking at. Pluto resides on the outskirts of our solar system. This little outcast is the definition of cold. The temperatures are around minus 380 degrees Fahrenheit. It has the weirdest orbit, too. Its orbit is very long, elliptical, and tilted. Pluto travels a huge distance from the Sun. That, together with an almost non-existent atmosphere, keeps Pluto in a perpetual cold state. Winters there can get a bit more extreme than average. However, the biggest shift someone stranded on Pluto would notice isn't the temperature, but the Sun's brightness. Always thousands of times fainter than our earthly view.
There are many different conditions on other planets and moons that could affect how your pet would evolve there. Take gravity, for example. On a bigger or denser planet, gravity would be higher, meaning that life would evolve to be shorter, sturdier, and perhaps with multiple limbs for structural support. On a lighter planet with weaker gravity, life could hop, soar, and glide more easily, and would be more likely to evolve a lighter, taller build. Mars is the 4th planet from the Sun, a dusty, cold, desert world. Mars is also a dynamic planet with seasons, polar ice caps, canyons, extinct volcanoes, and evidence that it was even more active in the past. Gravity on Mars is lower than on Earth, and it's farther from the Sun, so we would see less sunlight. Mars also has no protective magnetic field due to its thin atmosphere, exposing everything to radiation. Sometimes, strong winds create dust storms that howl around the whole planet, and the dust continues to settle for months after. Your pet dog on Mars would probably have a taller, robust build to compensate for poor gravity, and would have bigger eyes to better perceive the far-off sun. To protect itself from radiation, your dog would have to switch its pigmentation from melanin to carotenoids, which give carrots, tomatoes, and oranges their color. So the dog would probably have orange skin. Since Mars has weak gravity, your cat would probably be lighter and would jump more to get around the place. It would also have longer legs. Jupiter is called a gas giant. The planet is covered in thick red, brown, yellow, and white clouds. The clouds make the planet look like it has stripes. Living on the surface of Jupiter might prove to be challenging, since there's no actual surface. The planet consists entirely of gas, but it doesn't mean it's just a giant cloud hanging in space. If you venture through its atmosphere to deeper parts, the gas becomes denser until it turns into liquid. So one layer of Jupiter is an ocean made of hydrogen instead of water. With high pressure, extreme temperatures, and a fluid environment, we'll have to draw some inspiration from deep water dwellers who deal with the same conditions but on a smaller scale. Your cats and dogs would be big isopods with shells to protect them from Jupiter's radiation. Like its fellow gaseous neighbor Jupiter, Saturn is a gargantuan cloud of hydrogen and helium with no solid land and powerful winds. Like Jupiter, it gets tighter within, but its core is much smaller. Its iconic rings are made of a myriad of ice particles, so nothing could live on them, unfortunately. Saturn's volume is greater than 760 Earths, and it's the second most massive planet in the solar system, about 95 times Earth's mass. Saturn's average density is less than water, so this behemoth of a planet could float in a bathtub if there were one of a suitable size. The only way to move within Saturn's thick fog is by flopping around like a jellyfish. Your dog would probably have an umbrella-shaped bell to propel itself up, and no skeleton, so that it wouldn't be crushed by the pressure. Your cat would have jellyfish tentacles to move around. Life is tough on Mercury. This tiny planet is closest to the sun, so the sunlight here is 7 times more powerful than on Earth. No sunscreen would be able to manage that. Mercury is about 2/5 the size of Earth, with a similar gravity to Mars, or about 38% of Earth's gravity. This means that you could jump 3 times as high on Mercury, and heavy objects would be easier to pick up. Mercury's temperature is extreme, swinging between a scorching 800 degrees Fahrenheit during the day and negative 290 degrees Fahrenheit at night. It's all accompanied by constant meteor showers and quakes. As a bonus, there is a very thin atmosphere and no air to breathe. Flesh and bone could never handle these severe conditions, so instead, your pets here would be made of something similar to refractory metal, like titanium. There'd be no need for a respiratory system, so their pretty metal faces would be without a nose, and their eyes would probably look like thick sunglasses to protect them from all this sun exposure. If there's anywhere harder to live than on Mercury, it's Venus. Venus is the second planet from the Sun, and is Earth's closest neighbor in the solar system. Venus is the brightest object in the sky after the Sun and the Moon, and sometimes looks like a bright star in the morning or evening sky. The temperature here is a whopping 880 degrees Fahrenheit, and the atmosphere is so thick, it creates a greenhouse effect. The surface is dry and full of surprises like volcanic eruptions, hurricane winds, and lightning. And, as a cherry on top, the pressure here feels like you're 1 mile underwater, giving you a never-ending headache. It would be hard to imagine your pet living on Venus. The only things that could possibly survive there are anaerobic bacteria. Venus eats away at everything, even metal, making quick work of any human spacecraft. And Venus's atmosphere contains phosphine, which is toxic for anything that breathes oxygen, but means life for microbes. Icy, dark, and plagued by strong winds, Uranus and Neptune are mostly made of cold liquids, methane, water, and ammonia. Methane makes Uranus blue, and it has faint rings, while Neptune is dark, cold, and very windy, as it's the last of the planets in our solar system. It's more than 30 times as far from the Sun as Earth is. Neither of them has a solid surface, and their atmospheres slowly merge into the water around the planet's core. To boot, gravity on Neptune is stronger than on Earth, and applies more pressure on everything. With such powerful gravity, your dog would be shorter, and your cat would be stockier, with muscular bodies and thicker skins against the cold. And considering the fluid environment, your pet's best bet is to become like a cosmic whale or manatee, floating around the blue planets. Pluto is not very big. It's only half as wide as the United States. Pluto is smaller than Earth's moon. This dwarf planet takes 248 Earth years to go around the Sun. If you lived on Pluto, you would have to wait 248 Earth years to celebrate your first birthday. 1 day on Pluto is about 6.5 days on Earth. The farthest planet-like object from the Sun is appropriately freezing cold and covered with ice, with weak gravity and a flimsy atmosphere. The Sun, from Pluto, is nothing more than a dot on the horizon, much like the Moon for Earth, so there's not much going on in terms of light. But scientists suggest that there may be a water ocean under Pluto's surface and some nicer weather. Let's take notes from Earth's creatures with built-in antifreeze, like some insects and fish. Low gravity makes the muscles and bones shrink, and the space between vertebrae expand, making your pets taller. Their posture would also change, since their spine, for the most part, would be out of a job. So they'd probably be tall, thin, and somewhat spider-like, with spindly limbs and a curved spine. On other planets beyond the solar system, the boundaries between plants and your pets could be blurred, and your pets might merge with plant life. Your pets might become tree-like, with beating hearts attached to their bodies, or with feet to move to better positions as they compete for light and water. You could also have a rabbit that spends most of its time staying still, photosynthesizing, and only running away if threatened. Or a massive dinosaur-like horse that splays itself out on the ground to get nutrients directly from the soil and obtains extra energy with the help of plants on its back. Cooperation could lead to some fascinating pets, such as a sea of amoeba, acting as a single jelly-like mega-creature, thousands of voracious shrimp-like carnivores forming a single organism that devours anything in its way, or a web of intertwined trees that collect water in wide pitchers at the top of their canopies. Getting oxygen to muscles is a key for your pet's endurance. Here on Earth, octopuses use a copper-based molecule in their blood to shuttle oxygen, making them more sluggish than mammals and birds that use iron-based hemoglobin. Scientists have speculated about other types of oxygen transport that could make animals fitter. In atmospheres with more oxygen, we might see a pet monkey that can fly without ever having to stop for a rest. On cold planets and moons without much sunlight, such as the moons of Saturn and Jupiter, your pet dog might have to get by with chemical energy rather than take it from the sun. Also, in worlds without light, such as the depths of Enceladus's oceans, there might be little need to evolve eyes. Pets would probably sense their environments using other means, like gills and vibration sensors.
If one of the many apocalyptic scenarios come true and humanity is wiped out completely, a black box will tell whoever comes after us about what has led to that scary day. The 33-foot-long vault in a remote part of western Tasmania is supposed to document all the mistakes humanity has made that led to an apocalypse. The artists, architects, and researchers behind the Earth's black box hope that the art installation made of thick, reinforced steel will withstand fire, water, and any other natural disasters, except probably for total planetary destruction. Just like the black box you can find in planes, this time capsule is supposed to help the next civilization do better and avoid the probable sad and tragic fate of our humanity. The project is fully non-commercial and has an important message. The box will be full of storage drives and have access to the internet. Solar panels on the roof will power it, and batteries will take care of backup power storage. Whenever the sun's out, the black box will be updating itself with new scientific data. A special algorithm will sort it only to save the information relevant to the project. It will be measurements of land and sea temperatures, ocean acidification, species extinction, land use changes, as well as data on human population and energy consumption. The second type of data for the box will be newspaper headlines, social media posts, and news from the key global events focusing on the environment. The creators of the box decided to encode and store data for it in several formats, including binary code. The instructions on how to retrieve all that priceless knowledge would be etched into the outside of the box. Some of the big brains involved in the project are afraid that this could inspire some curious bad guys to break into the box long before it's time to do it. The solar-powered hard drive will have enough space to collect data over 50 years. Even the most pessimistic scientific models don't predict the end of the world any sooner anyway. It might even take centuries before the worst happens. The idea of a box that would record everything that happened before an accident in aviation was born in the middle of the 20th century. Back then, the world's first jetliner, de Havilland's Comet, crashed 7 times over 2 years, taking the lives of 110 people. The Department of Civil Aviation in Australia wanted to find the possible cause of all these crashes. One of these experts was Dr. David Warren, a chemist specializing in aviation fuels. he realized that there was simply not enough data to make any conclusions. There was no one to tell what had really happened before the crash. He remembered seeing a dictaphone that recorded sound on steel wire at a trade fair. Soon, Dr. Warren wrote a memo to his manager offering to design a voice recorder to follow what was going on in the cockpit. It would also record flight data and be stored in a crash-proof container. Flying wasn't a huge thing in Australia back then, so the manager didn't appreciate the idea. Dr. Warren then started working on a prototype in his own garage. He showed the ready device to the secretary of the British Air Registration Board when he was in Australia. He absolutely loved the idea, so later, Dr. Warren got a whole team to help him develop a pre-production prototype. The correct way to call his invention is actually not black box, but flight data recorder, and it's orange, not black. We probably call it black because those gadgets get charred black after a crash. Or maybe because the first boxes were painted that color to prevent reflection. Or because that's the general name scientists use for devices with in- and output of data with complex internal workings. So, the flight data recorder consists of two parts: the data recorder and the cockpit voice recorder. Historically, they were two boxes, but now they're just two cylinders. The data recorder keeps track of such important flight data as engine exhaust, temperature, fuel flow, aircraft velocity, altitude, and rate of descent. The second part records sound in the cockpit to analyze communication with air traffic control in case of an accident. The device only records data for up to 2 hours and then overwrites the previous sounds. Sometimes, the two parts are combined, and they look like a box. The devices record data and voices from the cockpit, but they are actually located in the tail end of the aircraft, where the structure of the plane will protect them best in case of a crash. The black box has a locator beacon, which is activated when water gets on it, but it will send out a pulse for 30 days. Search parties use the bright orange color of the recorder as a visual beacon. Sometimes, it takes a long time to find the box, and in some cases, they don't find it at all. Long before the first plane was invented, there was an original black box of planetary meaning, the ancient library of Alexandria. Back in the ancient days, people in places like Egypt, Mesopotamia, and Greece were no strangers to libraries and archives. But these early institutions were more about preserving local traditions and heritage. The whole concept of a universal library only became a thing when the Greeks started thinking big. They were so impressed by what their neighbors in Egypt were doing that they arranged expeditions to acquire knowledge. Alexander the Great, the king of Macedonia, seeing that hunger for knowledge required his companions, generals, and scholars to report to him in detail on regions that were previously unmapped. It helped collect plenty of information on geography and contributed to the creation of a great library. Most of the information it had was written in Greek. It had the books of Aristotle as part of the whole corpus of Greek literature. Some sources say that in the hunt for new books, the library's founders would stop every ship sailing into the harbor of Alexandria. If they found books, they would take them to the library. If they decided it was valuable, they'd make a quick copy and return it to the owner with some compensation, leaving the original at the library. Another story tells us that Ptolemy III, grandson of the founder of the library, offered the governors of Athens a huge compensation to copy the original texts of the greatest poets. He then kept the originals and sent them back copies. Once the Roman Empire arrived, they burnt all that knowledge, not thinking that it might lead to their own collapse. There was no easy way of spreading information across the world, so one source had most of the knowledge humanity had accumulated by then. The great minds of those times didn't just fill it with knowledge, but also made important connections, trying to make the best use of that information. If the Library of Alexandria hadn't burnt, we could have gotten some priceless knowledge about the people who had lived before the current era. Some scientists believe that big data could have saved the Vikings that had settled in Greenland many centuries ago. It might have also helped the Easter Island civilization to identify and address problems caused by volcanic activity, latitude, and rainfall patterns, and restore soil fertility. They say that a typical person living today is exposed to as much data in one day as someone in the 15th century would learn in their entire lifetime. And there's a theory that every papyrus scroll on the whole Library of Alexandria could probably fit onto an ordinary flash drive you have in your pocket. There's so much big data generated every day that it might do us more harm than good because of a huge information overload. We're moving towards a global civilization, so if all that knowledge disappears, we lose not one empire, but the entire world. Look at this fascinating planet. It looks as if it's burning. It must be hotter on its surface than in the middle of Death Valley. The ground is parched, cut by giant cracks. There's not a drop of water in this boiling world. Now, it's the same planet, but it looks like a totally different place. Everything is frozen. The temperatures are so low, there isn't even a tiniest chance that life could survive on this planet. This bizarre world is called HD 20794d, and it's located 19.7 light-years away from Earth in the constellation Eridanus. This planet is a super-Earth. This term means that it is larger than Earth but smaller than such ice giants as Neptune. What makes this planet especially interesting is its unusual orbit, which moves it in and out of its star's habitable zone, the region where temperatures might allow liquid water to exist. Now, we haven't seen this unusual planet directly. Astronomers detected it by measuring tiny wobbles in its star using two powerful instruments, espresso and HARPS, located at telescopes in Chile. These instruments measure radial velocity, which is the small movement a star makes as a planet's gravity tugs on it. The larger the wobble, the more massive the planet. Later, astronomers analyzed the data and figured out that the planet in question has a mass around 6 times greater than Earth's. It orbits a star, which is slightly smaller and dimmer than our Sun. What makes this star unique is that it is bright enough to be seen with the unaided eye, unlike many other stars that host exoplanets. You won't be able to see them without a telescope. The star system has been observed for over 20 years. Astronomers have long suspected it had multiple planets. In 2011, scientists discovered 2 other super-Earths orbiting the star every 18.3 and 89.6 days, respectively. For some time, researchers thought they had found a third planet with an orbital period of 40 days. Later, they realized they had made a mistake. But recently, after reanalyzing years of data, astronomers have confirmed that the third planet does exist, and it's our extreme HD 20794d. A researcher from the University of Oxford played a key role in identifying the planet. He used a special computer algorithm called Yarara to separate the planet's weak signal from the background noise. It helped him confirm that the planet truly existed and was pretty unique. Unlike the planets in our solar system, which have mostly circular orbits, the newly discovered one follows a highly elliptical, stretched-out orbit. It takes 647 days to complete one trip around its star. That's just 40 days shorter than Mars's orbit around the Sun. At its furthest point, the planet is twice the Earth-Sun distance, which makes it an icy world far outside the habitable zone. At its closest point, it moves inward to 0.75 AU, where it enters the habitable zone, where liquid water might exist. This extreme movement creates truly bizarre seasons. For some part of its orbit, HD 20794d is frozen, like an icy wasteland. As it approaches its star, temperatures rise and ice likely melts, forming temporary oceans. The planet then experiences a short, scorching summer. It is so hot that the water on its surface might evaporate into the atmosphere. Shortly after, the planet moves away again. It triggers a gloomy fall with rains, followed by a deep freeze in winter. In other words, the planet switches between extreme cold and intense heat, which makes it a very unpredictable place for life. If any life forms exist there, they certainly need to adapt to dramatic changes in temperature and environment. Why does the planet follow such a mind-boggling orbit? It might be a leftover effect from events billions of years ago, when the planetary system was still forming. At some point, another large planet may have disturbed the orbit of our extraordinary friend. Another possible explanation is that a giant planet once existed in the system, and its gravity pushed HD 20794d into an elongated path. Later, this giant planet may have been ejected from the system, leaving the smaller planet in its current orbit. This theory makes sense because the two other planets in the system, B and C, have more normal circular orbits. The discovery of this planet is so exciting because it challenges what we know about habitable planets. Most planets in the habitable zone stay there permanently, but HD 20794d only passes through it. Scientists want to know if such a planet could still support life, even briefly. So future telescopes will study the atmosphere of this planet, looking for signs of water, gases, or even life. Another super-Earth that might have the right conditions for life orbits a star 137 light-years away. In space terms, this is considered relatively close. A light-year is around 6 trillion miles. The planet is called TOI 715b, and it's about 1.5 times the size of Earth. Unlike HD 20794d, it's permanently located in the habitable zone. Look, that's what astronomers think the planet might look like. TOI 715b orbits its star very quickly, completing a full orbit in just 19 days. But even though it's close to its star, it may not be extremely hot, all because its star is a red dwarf. That's a type of star that is smaller and cooler than our Sun. This means TOI 715b could have a milder temperature compared to other exoplanets that orbit closer to hotter stars. NASA discovered the planet using the Transiting Exoplanet Survey satellite. This space telescope finds planets by watching for small dips in a star's brightness, which happen when a planet passes in front of it. Since red dwarfs are smaller and dimmer than the Sun, planets passing in front of them are easier to detect. Astronomers are planning to study the planet further using the James Webb Space Telescope. This powerful telescope, located 1 million miles away from Earth, can analyze the atmospheres of distant planets. If TOI 715b has an atmosphere, JWST could help scientists determine what gases are present in it and whether such conditions could support liquid water or even life. One more promising world for our search for extraterrestrial life is an extremely dense super-Earth in the K2360 system. An international team of researchers from Japan and Europe has discovered this remarkable multi-planet system orbiting a Sun-like star located 750 light-years away. This system has 2 planets, including one of the densest rocky planets ever found. The K2360b is a rocky super-Earth, about 1.6 times the size of Earth, but with a mass 7.7 times greater. This makes it as dense as lead. The planet orbits its star incredibly fast, completing one full orbit in just 21 hours. It's the densest known ultra-short period planet with well-measured properties. As for its sibling, this is a much larger outer planet with at least 15 Earth masses. It takes 9.8 days to orbit its star. Sadly, since it does not pass in front of its star from our viewpoint, scientists cannot determine its exact size. The unusually dense planet might be the core of a much larger planet. Over time, intense radiation from its parent star may have blown away its outer layers, leaving behind only its dense, rocky core. So, in fact, this planet could show us what might happen to some planets that are too close to their stars. Astronomers think that the planet may have moved inward over time due to interactions with its larger companion planet. One possibility is high eccentricity migration, where a planet's orbit becomes highly stretched out due to gravitational interactions before gradually becoming more circular near the star. Another theory is that the planet's spin and axial tilt can cause its orbit to become more circular. Such planets are rare, and finding one with a massive outer companion can help scientists refine their theories about how planets form and evolve in extreme environments. With its help, we might also understand how rocky planets evolve and what happens to planets that get too close to their stars.
Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star, and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers used different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star. which is not cool on many different levels. Kepler-22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth. It's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler-22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler-69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet. A new super-Earth has been spotted by astronomers, and it's quite intriguing. This planet, called TOI 715b, is about 1.5 the size of Earth, which is why it's called the super-Earth. It's also relatively close to us in space terms. only 137 light-years away. For comparison, most exoplanets are hundreds of light-years away, and all the interesting stuff, like black holes and nebulas, are usually more than thousands of light-years away from us. So, could it be habitable? The habitable zone is an estimate of where a planet might have the right conditions for liquid water. This is what we call some distance from the star where the temperatures on the planet should be okay-ish and water should stay liquid on its surface. It's not super precise because it depends on a bunch of factors like the type of star, how reflective the planet is, its size, and so on. Also, just being in this zone isn't enough for water to actually be there. The planet also needs the right kind of atmosphere and a few other things. So, we invented a stricter definition in 2014, the conservative habitable zone. It's a more precise term defining the best candidates that have liquid water. Otherwise, we get too many potentially habitable planets that are not actually habitable at all. The CHZ is based on how much energy a planet gets from its star compared to Earth. If a rocky planet gets between 40 to 85%, it's considered to be in the CHZ, no matter how far away it is from its star. These planets have a higher chance of being habitable. And yes, TOI 715b is located there. This super-Earth orbits the M-type star, also called red dwarf. It's a star that's much smaller and cooler than our Sun, about a quarter of the Sun's size and mass. But if the planet is located in the habitable zone, it's actually a better option for life. Red dwarfs live much longer than our Sun, a yellow dwarf. This also means that they have more time to form little creatures on their planets. And this red dwarf really is older than our star. Our Sun is 4.6 billion years old, and this star is 6.6 billion years old, give or take a few hundred million. It doesn't have much magnetic activity, so it's not dangerous. It doesn't flare up like younger red dwarfs. These flares can be super strong and might even hurt planets by taking away their atmospheres. Although some planets around it do have thinner atmospheres, it seems like this red dwarf has already gone all out. These red dwarfs are where we're looking for planets that could support life right now. Our super-Earth is really close to its star, zooming around it in just 19 days. Since the star is small and the planet is so close, the planet passing in front of its star happens a lot and looks really clear. This makes it easy for telescopes like the James Webb to study its atmosphere without needing too much time. Now, speaking of the James Webb Space Telescope, it's bringing us into a new era of understanding distant planets beyond our solar system. Imagine being able to see what gases make up the air on a planet millions of light years away. James Webb will help us to find worlds that could support life. Right now, it's trying to figure out whether TOI 715b has an atmosphere. If it does, its atmosphere might be easier to spot compared to a planet that's drier and denser. And then we might get even more height because it would look like a good place for life. On top of all that, there might be another planet in this system, also in the habitable zone. We're not sure whether it's really there, it's just a candidate with a crazy name. But if it turns out to be real, it would be about the size of Earth. Also, it would be the smallest planet in the habitable zone ever spotted by the TESS telescope. Now, another cool thing about TOI 715b is that it cannot just have water on it, but be an entire water world. An ocean planet is a type of planet that has an ocean covering its surface or has subsurface oceans. They might not have much dry land because the water can cover everything. Sometimes the entire planet can be covered in other liquids, like lava or ammonia. When it comes to planets outside our solar system, we can't see surface water directly with our current technology. Instead, scientists look for water vapor in the atmosphere as a hint there might be liquid water below. And of course, we wonder if these planets can have life, hopefully not in the form of Leviathan-like monsters. Our models show that planets with oceans might be pretty common in our galaxy. This means there could be lots of ocean worlds out there waiting to be discovered. But the most important part about TOI 715b is that it's in the so-called small planet radius gap. If we give the planets a lineup, there will be those that are bigger and smaller than Earth. But there's a sudden gap in planets that are about from 1.5 to 2 times bigger than ours. Where are they? This gap is interesting to scientists because it tells us something about how planets form and change over time. It's not that planets don't form in this size range. They actually start off larger and then lose some of their mass, like a balloon gradually deflating. Perhaps it happens because of how they orbit their stars, with stars blowing away some of their mass as they dance around it, as our Sun does with gas from comet tails. This gap holds a lot of mystery, and planets, like our new super-Earth, are clues that could help us unravel it. We aren't sure whether it exists around red dwarfs. Maybe it's a gap in how dense these planets are, rather than in their actual size. So studying our discovered planet is even more interesting. It'll help us learn more about distant stars and their planets. Now, I mentioned TESS a while back. NASA's TESS, Transiting Exoplanet Survey Satellite, has been in space for 6 years now and has been incredibly successful. NASA launched TESS because we already found over 5,000 planets orbiting other stars, mainly thanks to the Kepler telescope. But Kepler mostly found large planets, not necessarily like Earth. We decided to focus TESS on finding smaller Earth-like planets around nearby bright stars, making them easier to study with future telescopes. Here's how it works. The camera observes stars and looks for changes in their brightness. If the brightness suddenly drops for a while and then gets back, it could mean there is a planet passing in front of it. But stars can dim for other reasons too. For example, flaring up or having dark spots on their surface, which is why we need to be careful with this data. TESS shows us the size and orbit of these planets. Then ground telescopes help determine their mass. With these 3 parameters, we can figure out what the planets are made of and if they're rocky like Earth or gassy like Jupiter. Yeah, you want to avoid Jupiter after taco night. One example of TESS's discoveries was the TOI 700 system. There, it discovered its first ever Earth-like planet, TOI 700d. This exoplanet also orbited a red dwarf, and it's even closer to us, about 100 light-years away. Unfortunately, it's unlikely to be habitable because the temperatures there are crazy. Another big discovery was made in the AU microscopy system. TESS discovered a planet about 4 times the size of Earth and another nearly 3 times Earth's size. This system has become a key area for studying how stars and planets form and change over time. TESS has also spotted a variety of other exciting finds, including supernova, hot worlds, and so on. And as it enters its 6th year, we can only expect more exciting findings to come. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting, a big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. It's thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow-spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan's seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. that's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called Pareidolia. Our brains try to make sense of shapes, so when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist.
Tired of waiting for colonization? Does the Earth seem way too boring with all its problems and mosquitoes? Well, have no fear. It's time to take matters into your own hands and build your own planet. But before you start reaching for the cosmic glue and glitter, there are a few things you'll need to consider. Let's start our ultimate DIY project. First of all, we need to choose a location. Every planet has to orbit a star, right? In a cosmic buffet, every star has its own unique flavor. To keep things organized, astronomers use the so-called stellar classification system. The massive stars are the divas of the cosmos. They're huge, bright, and are always stealing the spotlight. But it's not all sunshine and rainbows. They have a short lifespan, burning out super fast, like a candle. They also have huge gravity, so be careful that your planet doesn't get sucked in. The dwarf stars, on the other hand, may be small, but they make up for it with their stamina. They can burn for trillions of years, which means that their planets have plenty of time to develop life. Super hot stars are blue or white ones, while the cold stars are usually red or orange. Yeah, seems like it should be the other way around, but we're not the ones making the rules. So what do we choose? Well, the planets around the blue and white stars could be scorched and fried, like a crispy chicken nugget. On the other hand, with cool red stars, our planet may turn into an ice ball. If that's your preference, then sure. But you can always pick a nice middle ground, a yellow star like our sun, for example. Not too cold, not too hot, but just right. Now that you've picked the star, let's start building the planet. The heart of the planet is its core. The core creates a magnetic field, an invisible force that protects a planet from harsh cosmic rays and charged particles. If it weren't for this field, the planet would be fried by the star's radiation, like a well-done burger. But the magnetic field isn't always a force for good. On some planets, like Jupiter, it's so strong that it creates super intense radiation belts and some crazy weather. If you were hoping to use a compass to find your way around on such a planet, forget it. The magnetic field would have the needle spinning like a breakdancer on caffeine. So, if you pick a small light core, the planet will have less protection from solar radiation, like tanning without sunscreen. On the other hand, larger cores can generate more heat, which can lead to more volcanic activity and earthquakes. The best option is a medium-sized core made mostly of iron and nickel, enough to keep the bad things away, but not too strong to turn a planet into a cosmic hot potato. Once the heart is in place, we can move on to the next step. Planets are like onions. They have layers. Most planets have three main layers: the core, the crust, and the mantle. The core is the filling, as we've already discussed. The mantle is like a hot and gooey layer of caramel between the crust and the core. And the crust is like a thin layer of icing on a planetary cake, covering its surface. But not all planets are built the same way. Because of that, we have tons of options. First up, we have the gas giants, the big boys of the universe. In our solar system, it's Jupiter and Saturn. They don't have a crust at all. They're basically huge balls of gas, like hydrogen and helium, hence the name. Next, we have the ice giants, like Uranus and Neptune. They're like younger, cooler siblings of gas giants. These planets don't really have a solid surface, but it's not pure gas either. They're made mostly of water, ammonia, and methane ice. There are also ocean worlds, and no, they aren't made of pure water. They do have some kind of solid surface, but it's located so deep, and the ocean on their surface is so huge that it kinda does look like a giant water drop. Finally, we have terrestrial planets, like the Earth. They're made mostly of rock and metal. These planets have a surface to stand on, and usually come with a cool mineral collection. And let's not forget about the dwarf planets, the small but mighty. Pluto is probably the most famous one, but there are others in our solar system: Eris, Ceres, Haumea, and so on. They're the scrappy underdogs of the planetary world, always trying to prove their worth, but never making it to full-fledged planets. Which type do you like the most? Gas giants are probably the coolest ones with their enormous sizes, crazy winds, and scary lightning. We also need to create an atmosphere. It's the outer layer of a planet that plays a huge role in its climate and weather. It's also the planet's ultimate protector. Did you know that 90 to 95% of meteors burn up in the Earth's atmosphere? Imagine what would happen if they didn't. Dense and hazy atmospheres, the ones you'll find on places like Venus, have thick layers of carbon dioxide and sulfuric acid. In other words, it's not a planet, but an oven. It's so hot that you could cook a pizza on its surface in no time and get cooked yourself. Next, we have thin and wispy atmospheres, like on Mars. The thin layer of carbon dioxide makes its surface pressure about 1% that of Earth's. On planets like these, you could fly like a superhero if you had a good enough jetpack. Then we have mixed atmospheres, like the one on Earth. The layers of nitrogen, oxygen, and other gases create the perfect conditions for life as we know it. It's also where we get to enjoy sunny days, rainbows, and of course, water. And last but not least, exotic atmospheres. You'll find them on planets like Neptune, where the layers of hydrogen, helium, and methane create a blue-colored world that looks like a giant marble. They're super weird and unusual, so just perfect for creative planet builders. Almost done. The final question is, would you like your planet to have life on it? In that case, there are some things you should consider. For example, it should be located in the habitable zone. This is the sweet spot around a star where conditions are just right for liquid water to exist on the surface. Make sure your planet isn't too close or too far from its star. And don't forget about the temperatures. For example, you'll want a good amount of oxygen for a planet to be nice and warm, but not too much that everything spontaneously combusts. Of course, we need some water, but not too much, and a stable climate. You don't want your planet to be going through extreme swings in temperature or moisture. That's a recipe for extinction, not evolution. Oh, and the orbit should be stable, so that there are no major astronomical events that could throw things off. As you can see, this type of planet is very picky. No wonder it's so hard to find extraterrestrial life. Anyway, now that we've finished messing around in the planet creation editor, how do we even build it? Well, how about terraforming? It's when we deliberately alter a planet's atmosphere, temperature, and other conditions to make it habitable for humans and other Earth-based life forms. For example, we could release greenhouse gases on Mars to warm up the planet and create a thicker atmosphere. But this method is more like polishing a monstrosity that was given to you by a character randomizer. What about building from scratch? That's something straight out of sci-fi. But maybe in the future, we could do that, using large-scale 3D printing or nanotechnology. we could create the basic structure and then add all the necessary conditions for life to exist. Of course, all this is still purely theoretical, but while creating a planet artificially is still a long way off, there are many creative ideas and concepts being explored by scientists and sci-fi writers. Who knows what the future might hold for the possibility of creating new worlds?
This planet, the one right here, shouldn't exist, but it does. A newly discovered planet rotates around a star that's much smaller and dimmer than our Sun. The planet, however, is enormous. Such a tiny star couldn't create it, so it's like finding an ostrich egg in a chicken coop. A team at Penn State built a special tool called the Habitable Zone Planet Finder. It's an instrument that's supposed to find planets around dim, cool stars. It's connected to a big telescope in Texas. The tool looks at the light from these stars, which is mostly in the near-infrared, beyond what our eyes can see. This gadget can spot changes in a star's speed caused by a planet. If the star movement slightly changes, that means there must be a gravitational pull nearby. Years ago, this technique helped find the first known exoplanet around a star like our Sun. Today, we've improved this method to make more precise measurements. Our main goal is to find Earth-like planets. They should be rocky and located in habitable zones, areas around stars where liquid water could exist. The Doppler technique isn't that great at finding Earth-like worlds yet, but works well for cool, dim stars. And that's how we discovered the impossible LHS 3154b. Planets usually form in disks made of gas and dust in space. Picture a flat, spinning cloud of tiny particles. These particles come together and stick to each other, creating a flat, rotating disk. Over time, these tiny bits combine to form a solid core. This is the starting point for a planet. Once the core is there, it attracts more dust and even gas like hydrogen and helium. But making a planet this way isn't easy. They need a lot of stuff, mass, and materials. This process is called core accretion. Stars are a huge help in that process. Usually, big stars have more gravity, so they can gather more stuff to form planets. But the star we discovered recently isn't very big. It's 9 times smaller than our Sun. A star this small shouldn't have a big enough disk to make a heavy planet. To do that, its disk should have been at least 10 times bigger. But this heavy planet, LHS 3154b, exists. Now, this mysterious planet is 13 times heavier than our Earth. It's similar in size to Neptune. It's about 50 light-years away from us in the Hercules constellation, which, in space terms, is very close. The planet is also super close to its star, completing 1 year in almost 4 days. This discovery is making scientists rethink their ideas about how planets and stars come into existence. There are new theories coming around. For example, a theory called gravitational instability. It says that, instead of the pieces coming together bit by bit, the material in the disk collapses all at once, directly creating a planet. But even with this theory, it's hard to explain how such a heavy planet could form without a really massive disk. It'll take us some time to figure out the truth. This isn't the first planet that makes us doubt our theories. Recently, scientists found another planet called Hala. This planet is orbiting a star called Baekdu, and just like the previous one, it shouldn't really exist. It's way too close to its star. Stars change a lot during their lives. Normally, when a star becomes big and prepares to leave this world, it's called the red giant stage. A star like that tends to destroy or push away any nearby planets, creating a huge mess. Hala rotates around a red giant, and it should have been swallowed or destroyed by the expanding star a long time ago. But it's still hanging there. Even though Baekdu has already started burning helium and shrunk to a smaller size than expected, Hala isn't bothered in the slightest. Scientists call Hala the Forbidden Planet. This discovery challenges what we thought about how planets survive near aging stars. It raises 2 theories. One suggests that Baekdu was once 2 stars, a white dwarf and a red giant. Hala orbited them both, and they merged before the red giant fully expanded. This allowed Hala to survive because the extra helium from the white dwarf prevented the red giant from growing too much. The second theory says that Hala formed from the debris created when the two stars merged. In this scenario, Hala would be a very young planet orbiting an elderly star. Astronomers plan to continue studying Hala and look for more planets like that. Another oddball, besides me, is called LTT 9779b. This one scares us too because it's too shiny. The planet reflects 80% of the light from its star. Regular mirrors reflect from 85 to almost 100% of light, which means that this mysterious planet should look like a rough mirror, with aluminum or silver-like reflections. This is another Neptune-sized planet. It's located 268 light-years from us and was discovered by NASA's TESS spacecraft. It completes a full rotation around its star in just 19 hours. It's so close to its star that it's scorching hot, reaching temperatures over 3,600 degrees Fahrenheit. Normally, planets this close lose their atmosphere and turn into bare rocks. But this one breaks the rules again. Now this time, we know the secret of its survival. It's because of the planet's shiny metallic clouds, which are made of glass and titanium salt. These clouds rain titanium onto its hot surface. They also reflect a lot of the light, preventing the planet from getting too hot and losing its atmosphere. It's like having a mirror shield. This planet's size also surprised scientists. It's way bigger than Earth. Other planets this close to their stars are either much bigger gas giants or small rocky planets. This planet is a smaller gas giant, and scientists didn't expect it to exist so close to its star. This is the shiniest planet ever found, even shinier than Venus. But despite its cool appearance, it's probably not a friendly place for life because of its extreme temperatures and strange metallic rain. And our final rule breaker is a planet called WASP 107b. Scientists discovered it using the James Webb Space Telescope. It's located around 208 light-years from us in the Virgo constellation. It's also fast and completes an orbit around its star in just 6 days. This is a super Neptune exoplanet. It's similar to Jupiter in some ways, including the same size and scorching hot temperatures. But the main difference is that it's much lighter, weaker, and less dense. This is the least dense planet we've discovered so far. After researching some more, we also found that it has a tail. The helium on the planet extends beyond the transit egress. The planet is slowly losing its atmosphere due to extreme ultraviolet radiation from the star. This creates a comet-like tail. So, it looks like a fluffy comet. But that was just the beginning. The planet's low density, or fluffiness, allowed astronomers to study its atmosphere in detail. They found some surprising things, like water vapor and clouds made of fine silicate particles, which are like really fine-grained sand. The planet's host star doesn't emit a lot of high-energy light. But since WASP 107b is so loose, the light can penetrate deep into its atmosphere. This creates sulfur dioxide that smell when you light a match. In other words, it's a fluffy planet that rains sand and smells like matches. The researchers think the sand clouds in the atmosphere form in a similar way to clouds on Earth. They just have droplets of sand instead of water. These sand droplets condense, fall, turn into silicate vapor in hot layers within the planet, and then rise again to form clouds once more. And, once again, this planet couldn't have formed in its current spot. Astronomers say that it likely moved closer to its star from a birth orbit because it was attracted by some heavier neighbor. It also follows a retrograde orbit, meaning it orbits in the opposite direction to its star's rotation. All these discoveries are changing how we understand planets and their atmospheres, giving us new insights into the mysteries of our own solar system.
This planet is as light as that piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b, but let's call it the Cotton Candy Planet. It's located around 1,200 light-years away from us. Sure thing we'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin, 50% more massive. It has an extremely low density combined with other factors, such as high temperatures and the infrared brightness of its host star, that make it look special. May I have a close-up here, please? Thank you. See how fluffy it is? Right now, you understand that it would be impossible to stand on its surface. Anyways, it's not often that you meet something like WASP 193b at a planetary party. Such planets might be fluffy because they're getting cooked by their parent stars, puffing up like a marshmallow that's seen too much campfire action. But the thing is, if you're that close to your star and mostly made of a hydrogen-helium cocktail, you're not gonna keep your puffiness for long. It's like trying to hold on to a balloon during a hurricane. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 100-07b, and it looks squishy too. This one kicks back 200 light-years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet is a copycat of Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure, but WASP 100-07b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI-cam. They spotted clouds made of the stuff that builds beaches, silicate, or as you might know it, sand. Imagine sandcastles in the sky! Those sound clouds are way up there in the penthouse suite of WASP 100-07b's atmosphere, where the thermostat reads a breezy 932 degrees Fahrenheit. Normally, you'd need 1,832 degrees Fahrenheit to cook up this kind of cloud, so scientists are scratching their heads. How did those grainy puffs get all the way up there? Turns out, WASP 100-07b might be running its own sandy water cycle, but with scorching silicates instead of H2O. Silicate particles get whooshed up from the sizzling lower levels by some sort of cosmic elevator, and then they cool off, party together as clouds, and sprinkle down a silicate drizzle. Nobody's packing sunscreen for this kind of sandstorm, though. Now look at this Kepler planet family located in the Kepler 51 star system. This cosmic three-pack hangs around 2,400 light-years away, looking huge but having the same density as your favorite snack. And it's cotton candy yet again. Scientists have been digging into what these space treats are made of. They now believe these puffball planets are big hydrogen-helium gas balloons with a generous smearing of methane haze. It also turns out these planets might be going through a cosmic downsize. Now, let's talk about a planet called Mascara 5b. Nope, it doesn't look like one of those cosmetic tubes from your mom's drawer. Scientists say it's one of the hottest planets ever discovered. They call it an ultra-hot Jupiter, showing off its impressive size, almost twice as big as our very own Jupiter. The dayside temperature is around a scorching 4,892 degrees Fahrenheit, while the night side hits 4,172 degrees Fahrenheit. No chance for any sort of life to survive out there. Actually, it's the second hottest nightside temperature ever recorded. To put it in perspective, the temperature of molten lava sits between 1,292 degrees Fahrenheit and 2,282 degrees Fahrenheit. So, the planet is a whole lot hotter than this scorching liquid rock. Its temperatures even surpass the melting point of most metals, which is around 3,632 degrees Fahrenheit. Scientists mention that the insane heat on this planet is comparable to the exhaust of a rocket engine. Back in 2005, one famous star called... Wait, is that a name or a phone number? Whatever. So, turns out this star has a hot sister, and they have very similar names. This hot sister has B at the end. Well, this place looks like something from a sci-fi movie as it rocks a mesmerizing blue marble vibe, according to NASA. Such an appearance results from an atmosphere packed with hazy clouds laced with glass. The rain on this planet is glass-filled precipitation that likes to fall sideways, thanks to fierce winds blowing at a speed of 5,400 miles per hour. And yeah, It's the hot sister for a reason. Scientists have measured the daytime temperatures in this nightmarish world. It's around 1700 degrees Fahrenheit. So when it rains on this planet, it's more like molten glass pouring down instead of your typical waterworks. You may not know it, but space is swarming with wasps. I'm talking about planets called WASP. Meet WASP 76b. This sizzling hot Jupiter-like planet is so out of this world, it rains iron at night there. The daytime side is no less of a fiery nightmare. The temperature there is about 4,300 degrees Fahrenheit. WASP 76b may be slightly smaller than Jupiter, but don't underestimate its grandeur. This fireball is located 640 light-years away from Earth, and its terrifying climate is the result of one seriously extreme orbit. You see, these gas giants are fittingly known as hot Jupiters. They like to keep it hot, so they orbit way too close to their scorching host stars. In this case, WASP 76b is nearly 10 times closer to its star than Mercury is to our Sun. That's way too close for comfort, leaving this rebellious planet tidally locked to the star. So, while one side basks in eternal light, the other is trapped in perpetual darkness. 55 Cancri E is a total gem. It's the raddest super-Earth ever spotted. Scientists initially believed it was packed with so much carbon that its insides were blinged out with diamonds, thanks to insane pressure and sizzling temperatures of 4,892 degrees Fahrenheit. But researchers put a dent in the diamond hype, showing there was actually less carbon than we had originally thought. Well, diamonds aren't actually that rare and expensive after all. They're just well marketed. The last destination for today is GJ 1214b, located 40 light-years away from Earth. This planet is like a supersized Earth, almost 3 times bigger in diameter and a whopping 7 times heavier. It orbits around its red dwarf star faster than you can finish a pizza, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on GJ 1214b create some super cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo on being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated.
The Moon is the Earth's closest space neighbor and its only natural satellite. It likely formed when a huge Mars-sized object crashed into our planet billions of years ago. I wasn't around then. This catastrophe turned Earth into a scorching ball of molten rock. It also pushed some material into its orbit, creating the Moon. Now, this heavily cratered sphere moves around our planet. This causes high and low tides around the globe. A bit more than 1/4 the size of Earth, it's the 5th largest natural satellite in the solar system. The Moon has several phases. For example, new, full, or crescent moon, first and last quarter. But whatever the satellite looks like, you can always find it in the night sky, and sometimes even during the day. But imagine waking up at night and noticing that the Moon looks somewhat different than usual. It seems brighter and bigger. It's hardly noticeable, especially when you're half asleep. You go back to bed, unaware that instead of the Moon, you've just seen Mercury. Close up, this planet, the nearest to the Sun, is similar to our natural satellite. Its surface is littered with craters left by space rocks. Mercury is about 2/5 the size of our planet, but it's still a bit larger than the Moon. That's why the planet would have a greater influence on Earth. Nights would become brighter, high tides would become higher, and low tides, what do you think, lower? Yup. The lunar cycle, that's the time the Moon, or rather Mercury now, needs to go through all the phases, would become 14 hours shorter. But all in all, such a replacement wouldn't have any drastic consequences for our planet. But then, how about Venus? What if, instead of the familiar satellite, we swap in the third brightest natural object after the Sun and the Moon? It's often called Earth's sister planet because their mass and size are nearly the same. Venus would be as large in our sky as Earth once appeared to the Apollo astronauts when they looked at it from the Moon's surface. The morning star would be much brighter than the Moon. For one thing, the planet reflects 6 times more sunlight. Plus, it would occupy an area at least 16 times larger. That's why nights on Earth would be as bright as early twilight now. If you looked at Venus, you'd spot vague swirling patterns in the planet's yellowish-white cloud cover. Venus wouldn't become Earth's satellite. The two planets would likely orbit around their common center of mass, and this orbit would be quite eccentric, like me. But if Venus moved with the same speed as the Moon has now, the two planets would crash into each other in the nearest future. Uh-oh. Okay, let's pull another switcheroo. If Mars was up there in the sky instead of the Moon, you'd surely notice it. Even without a telescope, you'd be able to marvel at its unusual color and dark spots on its surface. And even if you didn't see the red planet, you'd still feel something unusual. Mars is half of Earth's size, but several times larger than the Moon. Replacing a smaller space body with a much bigger one would upset the delicate balance on our planet. If you were unlucky to be at the seaside when Mars took the Moon's place, you'd have to evacuate as soon as possible. Massive waves would rise in the oceans under Martian influence. They would crash against the shoreline like the largest tsunamis. Mars would be reflecting more sunlight than the Moon. Nights would be lighter. Terrestrial landscapes would have an eerie red tint. And you'd be able to admire the tallest mountain in the solar system, Olympus Mons, through a telescope. Mars isn't large enough to change the Earth's orbit dramatically. But with time, the two planets would probably begin to orbit each other, creating a binary planet system. And since Mars would literally be next door, voyages to this planet would become a reality. Okay, now think really big. If Jupiter replaced the Moon, Earth, as an independent planet, wouldn't exist anymore. It would instantly turn into another moon of the largest planet in the solar system. The only positive moment in this transformation? People would have an awesome sky view. Jupiter is dozens of times larger than the Moon. A gigantic, beautifully striped sphere would cover nearly all the horizon. If you had time to enjoy the show, you'd see yellow, brown, red, and white clouds floating in Jupiter's atmosphere. Sadly, the gas giant's gravitational pull would instantly cause severe earthquakes, volcanic eruptions, and tsunamis. Earth's mantle and crust would be drawn toward Jupiter, which would break the planet apart. It'd be stretched and compressed with such force that its surface would bulge back and forth by more than 300 feet. Unfortunately, Earth's speed is only 10% of the speed needed for us to stay in Jupiter's orbit. That's why our sluggish planet would crash into the gas giant in less than a day. Well, that sounds unpleasant, so let's not do that. Now, if Saturn were to replace the Moon, it would be a sight to behold. The planet is more than 35 times larger than our satellite. It means the giant golden globe would cover 18 degrees of the sky, and its rings would stretch even further, from horizon to horizon. Hey, if you like it, then you should have put a ring on it. Earth would be a bit further away from the gas giant than its own moon, Dione. And since Saturn is way more powerful than our planet, Earth would turn into its satellite, not the other way around. Unfortunately, Earth's rotational speed wouldn't be enough to keep up, and we'd most likely crash into the much larger planet within a day or two. But before burning up in Saturn's atmosphere, we'd have to pass through its magnificent rings. They're made up of pieces of comets, asteroids, and shattered moons. It wouldn't be an easy feat to get through this space debris. Plus, our planet would have to avoid Saturn's moons, all 53 of them. But what if the fall didn't happen, and Earth did turn into Saturn's 54th moon? Then the gas giant's gravitational pull would lead to massive tectonic shifts all over our globe. They would be tearing the planet's crust apart until there's nothing left. Not good either. Both Uranus and Neptune are ice giants. These planets are the same size, larger than Earth, but smaller than Saturn and Jupiter. They both have icy interiors, deep atmospheres, and similar color, very beautiful bluish-green. If either of these planets replace the Moon, the consequences would be the same. So, let's flip a coin. Okay, it would be Neptune you'd see in the sky one day. Neptune is 14 times larger than the Moon. The planet would look like a bright blue hot air balloon in the sky, not only at night but during the day too. It would appear to be 15 times larger than the Sun. If everything else remained the same, a solar eclipse would seem to continue for ages. Once the Sun vanished behind Neptune's edge, our planet would be plunged into complete darkness for no less than an hour and a half. Neptune is 17 times the mass of Earth, and its gravitational pull is much stronger. That's why our planet would end up as a satellite. Yep, again. It would orbit Neptune slightly further than its own largest moon, Triton. By the way, there would be a great risk of Earth colliding with this space body. But let's assume we were lucky enough not to cross paths with Neptune satellites. Even so, there would be more than enough problems on our hands. Tides on our planet would become 1,000 times more powerful than those caused by the Moon. Neptune's gravitational force wouldn't pull Earth apart, but it would heat our planet up. The seismic activity would increase, setting off earthquakes and volcanic eruptions. And probably louse up the internet too. In 2021, astronomers announced that they had found between 70 and 170 free-floating planets. Such planets are also called rogue, because they don't orbit around any star. And the majority of these huge unattached planets, each approximately as large as Jupiter, dwells in one particular region of the Milky Way galaxy. It's known as the Upper Scorpius OB Stellar Association. Wow, doesn't it sound like the name of some homeowners association? Anyway, this conclusion was made by a team of astronomers that used telescope observations from all over the world and in space. They also looked through 80,000 wide-field images taken over a couple of decades. Scientists have estimated there might be billions or even trillions of rogue planets wandering around our galaxy. If their estimations are true, it might mean that the Milky Way contains more free-floating planets than stars. Ooh. This region of the sky is around 420 light-years away from Earth. A lot of amateur astronomers are familiar with it, since lots of cool stuff is located there. The most famous targets for astrophotographers include dark nebula, like Barnard 68, Coal Sack, or Pipe Nebula, as well as the colorful region around Rho Ophiuchi. But let's get back to mysterious rogue planets. They wander the galaxy alone, totally untethered. Without stars, they don't have days or nights, only eternal darkness. Of the thousands of planets scientists have detected outside of our solar system, only a dozen or so are starless and cruising on their own. Recently, astronomers have announced one more finding: the tiniest known rogue planet. The mass of this space traveler is somewhere between the masses of Earth and Mars. The term itself, a rogue planet, suggests that such celestial bodies might desert their stars on purpose. They wander off on their own, carving a new path through the Milky Way. But the reality is much more tragic. Rogue planets are usually kicked out of their star systems, doomed to a solitary existence of circling the center of the galaxy on their own. How sad. You see, things get messy when planetary systems, including ours, form. While planets appear from the cosmic dust surrounding a newborn star, they jostle one another around. This gravitational game of pool can easily shove some planets toward the edges of a star system, or eject one or two of them altogether. Then there are also nearby stars that can shove planets around too. Most stars are not born on their own. Clusters of dozens to thousands of stars often appear in space. No wonder that in such a crowded environment, a star with its own set of planets might whisk away a planet or two from another star. After stealing a planet, it can keep it for itself or cast it out into space. At the same time, some free-floating planets might form in a different way, with no parent star to help them. They appear from collapsed clouds of gas and dust, just like stars do. But sadly, they don't manage to put on enough weight to start nuclear reactions, the ones that make stars emit light. These objects are also known as failed stars. Hey, who said they failed? And they resemble planets. Rogue planets are very hard to detect. When astronomers want to find an exoplanet, they look for something blocking the light of its parent star. That's usually the planet passing between the star and the observer. But researchers can't use the same technique with free-floating planets because, in this case, there's no parent star. The only way to locate them is to rely on gravity. Now, imagine a line of sight between a telescope on Earth and a distant star. When an object crosses that line, its presence is likely to bend and magnify the star's light. This, in turn, makes the star appear brighter than usual. As for the duration of this brightening, it depends on the nature of this moving object. If the brightening lasts a few days, it's a star. If the duration is about a day or so, it's a Jupiter mass object. And if it's just a couple of hours, this object is something that equals the mass of our planet. But the trickiest part is to figure out whether this object is indeed a rogue planet. It's true that stars whose light such celestial bodies bend can't be their parent stars. They're too far away. But there still might be a parent star, invisible because of the glare of the luminous star. And astronomers have to wait up to a decade for the luminous star to move a bit to check for a potential parent star. If there's still no parent star in sight, then it's proven the planet is traveling solo. One thing is clear: without parent stars to warm them, rogue planets are frozen worlds. Even if ice doesn't go all the way down to their cores, it certainly covers such planets with hard, icy shells. On the bright side, maybe free-floating planets aren't as lonely as we think. They might have moons of their own. They probably take them along when they get pushed out of their cosmic homes. Even more exciting, these exomoons might have liquid water. At least that's what a 2021 study published in the International Journal for Astrobiology claims. Actually, I don't get that magazine, but it sounds fancy. But could a free-roaming world find a new home near a different star? Some experts think it's unlikely. The universe is an incredibly spacious place, and even a large star is hardly able to slow down enough to lasso a fast-moving planet. For example, in 2017, an interstellar guest, an asteroid the size of a skyscraper, appeared in our solar system. It barreled through the solar system and just kept going without stopping or slowing down. But what if it was a rogue planet? Would it stay with us? Astronomers say it's unlikely. If it happened, they would be thrilled, such a research opportunity. But the rest of us would likely be terrified by the implications of having such a neighbor. At the same time, maybe it wouldn't be such a big problem, considering how big and very empty our solar system is. But even without a rogue planet invading our solar system, the orbits of our planets are going to change one day. In 5 billion years or so, the Sun will start to dim. It'll begin to lose its mass until its gravity is too weak to hold on to the outermost planets of the solar system. Neptune, Uranus, and probably Pluto might turn into rogue planets. They will slowly drift away, unbothered by the cold and mostly unchanged due to their already frozen environments. And yeah, I know the scientists demoted Pluto as a planet years ago, but it's still a planet to me, so sue me. And what about Earth? Oh, our planet will have a different fate, much more tragic. As stars lose mass nearing the end of their lives, they eject gas and dust in all directions. And since our planet is in the way, it'll most likely get enveloped in this scorching stream and vaporize. But calm down, it won't happen for a few more billion years. And who knows where humanity will be at that time. As for now, astronomers hunt rogue planets with enthusiasm. For example, NASA's Nancy Grace Roman Space Telescope is going to conduct a survey to discover more free-floating exoplanets using its powerful techniques of a wide-field telescope. The stars in our Milky Way galaxy move all the time, and chance adjustments of the telescope can help researchers spot rogue planets. But there's one drawback: we won't know the distance to such a planet even if we find one. There's one more mission concept, cleverly called Cleopatra. It might be able to exploit parallax effects to calculate the distances to rogue planets. Parallax is a shift in the position of a foreground object when seen by observers in slightly different locations. To maximize this effect, Cleopatra might hitch a ride on a Mars-bound mission. It's supposed to place it in orbit around the Sun. That's a sufficient distance from Earth, which can help the mission effectively measure the parallax signal and fill in the missing information for astronomers. Okay, it seems scientists have come across a strange object in space, and they're not sure if it's a star or a planet. What we do know is that it's located 1,400 light-years away from us, and it makes us question what we thought we knew about the universe. Let me explain the dilemma here. We can tell if something is a star or a planet by considering the object's mass or the amount of stuff it has. Stars have a lot of mass, which gives them strong gravity that squeezes them tightly. Squeezing creates high temperatures inside them, causing them to shine brightly. Planets have less mass, so their gravity is weaker. They don't experience the same squeezing or high temperatures as stars. Instead, planets shine because they reflect the light from their stars, like our beautiful Earth does with our Sun, too. And this weirdo falls somewhere in between, since we consider it a brown dwarf. It's a special type of big, gaseous protostars. Brown dwarfs are usually like Jupiter in terms of their atmosphere, but they are much larger in size, about 13 to 80 times. If a brown dwarf has more than 80 times the mass of Jupiter, it can start burning regular hydrogen, just like a star. That's what usually makes stars shine brightly. But normally, brown dwarfs are not as hot as stars. Their inability to burn hydrogen has even earned them the nickname of failed stars. They burn at around 4,000 degrees Fahrenheit, which is cooler than most stars. But this object defies the norm. Its temperature measures an incredible 13,900 degrees Fahrenheit. Now let's put that into perspective. The hottest day in history was reported to happen in Death Valley, California, more than 100 years ago, with a temperature of 134 degrees Fahrenheit. People back then must have felt like they were melting along with everything around them. Now imagine getting closer to the Sun, like taking a trip to Venus. Venus can reach insane temperatures of 860 degrees. It's not only about the distance, though. Mercury is the planet closest to the Sun, but it's still colder than Venus. Venus is extremely hot due to the greenhouse effect. Did you know that Venus could have been a delightful place to live a long time ago? Or at least be home to any form of life. But at some point, it started to trap carbon dioxide and eventually created this thick, smoggy oven that doesn't release heat. And that's why it's so hard to explore. The longest a probe managed to last on Venus was 2 hours. But hey, that's longer than I can do at work, and then I melt. So yeah, then you get to the Sun. Its surface burns at an incredible 9,930 degrees Fahrenheit. And what's fascinating is that this weird brown star we're talking about is hotter than that. I mean, it's not hotter than the Sun's core, whose temperatures go up to 27 million degrees, but it's still very impressive and unusual for a brown dwarf to be this hot. At least that's what everyone thought until they realized why it was happening. The brown dwarf is remarkably close to another star that falls into the category of white dwarfs. They're so close to each other that our mysterious star makes one orbit around its white dwarf friend in just 2.3 hours. Woo! How old we'd be over there! Since they're this close, they're tidally locked like our Moon and Earth. That means one side of this brown dwarf always faces the white dwarf, and the other side is forever in darkness. Because of all this, our brown dwarf is superheated on one side only. So its day side is what got us confused. While the temperature on the night side is what you would expect from a brown dwarf. But these extreme conditions won't last long. Such a hot temperature makes the molecules in the dwarf's atmosphere break apart into individual atoms. And while its molecules are falling apart, this brown dwarf is slowly disappearing. And if you think this brown dwarf is hot, what would you say about Eta Carinae? It's a star located about 7,500 light-years away from Earth, and it belongs to an elite group of stars we call luminous blue variables. One astronomer first noticed it in the 17th century, but back then, it was just a regular medium-bright star. Almost 200 years later, another astronomer was observing it. But this time, it was a very bright star, one of the brightest ones in the sky. A few years later, it reached the highest level of brightness in a big event called the Great Eruption. When it happened, the star could be easily seen in the night sky. It released so much light, as much as is emitted in a supernova explosion. It remained like that for a couple of years, which is not what usually happens with exploding stars. After the party reached its peak, the star decided it was time to leave. It's still hesitating though, so it's still alive but dimmer than before. There's a nebula around Eta Carinae too. It is a shell made of gas and dust that formed during the Great Eruption. It even blocks some of the star's light. Eta Carinae is a binary star system. That means there are two stars that orbit around each other. One component has a temperature of about 26,500 degrees and the other 62,500 degrees. The main star in the Eta Carinae system, which is the more massive of the two, is 100 times heavier than our Sun. Because of its enormous mass, scientists predict that this star may eventually explode in a powerful event known as a supernova. But not for another several thousand years. So, by now, you might have already guessed what the hottest thing in the universe is. Ta-da! A supernova. The supernova is what tells us that the life of a star has ended. We're talking about the most powerful explosions in space. They happen when a star that's between 8 and 40 times more massive than our Sun flops. Its core can no longer create enough energy through a process called fusion, so the star can't even handle its own gravity. It's like a stellar burnout, too much work a star can't handle, and its core just collapses. During a supernova, the temperatures in the star's core can get 6,000 times higher than in the core of the Sun. Or sometimes, a specific type of star called a white dwarf suddenly restarts its nuclear fusion, and bam, you get a supernova again. Kepler's supernova happened at the beginning of the 17th century, and it was the last really big supernova event we directly observed from Earth. On average, supernovas in our galaxy happen 3 times every century. I mean, we got a smaller supernova in 1987 too, when a blue supergiant exploded in one of the Milky Way's satellite galaxies, which we know as the Large Magellanic Cloud. This explosion was so strong, people could even observe it with the unaided eye, even though it was incredibly far, 168,000 light-years away from our home planet. What a topic for summer days, huh? But check this out. We can also talk about the hottest thing people have ever created, made in a surprising place, Switzerland. Nah, we're not talking about a super hot chocolate. A group of scientists there created a subatomic soup called a quark gluon plasma. In this experiment, the temperature got 250,000 times as hot as the Sun's core. The purpose of this experiment was to recreate the conditions that existed shortly after the Big Bang, when the universe was still in a state of chaos. Okay, let's get even more extreme. In theory, things can get even hotter. Have you heard of the Planck temperature? It's an insanely hot temperature with numbers so high we can't even imagine. A supernova is like tepid tea compared to this madness. And who even knows what the matter does at these temperatures? Okay, I'm done. Now we take you back to your regular universe. Bye now. Now, space missions used to be this big deal, but now they're starting to feel like a walk in the park. But there's a catch. Our bodies aren't exactly built for surviving on other planets. Now, I know what you're thinking. Our bodies will eventually adapt and evolve, right? Well, yeah, evolution is always on the clock, but let's be real here. It's not going to happen overnight. We're not talking about a cool million years for some changes to kick in, and honestly, who's got the time for that? So, how about tweaking our genes just a little bit to make living on other planets easier? Genetic modifications are all about changing an organism's genetic material, like its DNA, to give it some cool new traits or characteristics. Now, picture this. Scientists could totally mess around with our genes to make us more resistant to crazy temperature. You know, like the temperature fluctuations of the moon, minus 298 degrees Fahrenheit at night to 224 degrees Fahrenheit daytime. Wow. They might even figure out a way to make us super tough against radiation, which is a huge deal in space or on planets with weak atmospheres. We definitely don't want to get fried out there. Oh, and here's another thing they could do: tackle the effects of low gravity. Spending too much time in low gravity can really mess up our muscles, bones, and even our heart. But if they tweak those genes related to muscle and bone growth, we could become super strong and resistant to all those nasty effects. However, it's not as simple as it might seem. The technology for safe and precise genetic modifications is still in its early stages, so it might even take as much time as it would for our bodies to naturally evolve and adapt to other planets. There are a couple of nice exoplanets where humanity might potentially live. I'm talking about Gliese 667 cc, Kepler 442b, Kepler 62e, Kepler 452b, Gliese 837, you name it. In fact, I'm sure you can do a better job of naming than these. Now consider Gliese 667 cc. In fact, let's nickname this one Gary for short. Turns out that Gary gets about 90% of the light that Earth does. But instead of regular visible light, this planet mostly gets infrared light. To put it simpler, Gary is rocking only 20% of the visible light that Earth gets. Yep, it's a bit darker over there. So, do we need really warm clothes and night vision goggles to thrive on this planet? Nah, not really. In addition to darkness, Gary is estimated to have a higher mass than Earth, meaning it likely has a stronger gravitational pull. To adapt, humans would need to hit the gym at least twice a day. Translation? Humans would need to develop stronger muscles and bones to withstand the increased gravity. Over generations, natural selection might favor individuals with these adaptations. We still know too little about these exoplanets to move there anytime soon. Hey, how about some planets in our solar system? Let's discover our top picks. This way, we can easily figure out what changes we need to make. So, first things first, let's eliminate the two ice giants in our solar system and their friends. Yep, Neptune, Uranus, and the two gas giants Saturn and Jupiter. Sorry guys, but terraforming you is just not gonna happen. Even so, we still have 4 super cool candidates right here in our solar system. You all know them well: Venus and Mars, the popular kids on the block. And then we have Jupiter's moon, Callisto, and Saturn's moon, Titan. They might not be as famous, but they've got some serious potential to become Earth 2.0. So, it turns out some of Jupiter's moons are super cool for terraforming. They're packed with water, which is a big plus. But here's the catch: only Callisto is far enough from Jupiter's radiation belts. You see, on Earth, we get hit with about 0.24 rems of radiation per year. But, for instance, Ganymede, another of Jupiter's moons, gives away a whopping 8 rems per day. Just to make it clear, professional workers here on Earth can have more than 5 rem per year. Callisto is different though. We don't need to tweak our genes, as it only gets about 0.01 rems per day, which we humans can totally handle. Now, let's not get too carried away with the idea that life on Callisto is all sunshine and beaches, like in California. Nope, it's more like an icy wonderland out there. So if you ever find yourself on Callisto, make sure to pack your snazziest protective clothing and some high-tech heating systems. Honestly, at this point, we might as well wish for evolution to take us back to our furry animal days. I mean, think about it. Our ancestors were rocking some serious fur game, just like those cool chimps and gorillas. But as time went on and we got all fancy with our evolution, we decided to ditch the fur coat and go for a more minimalist look. Now, why did we lose our fur? That's a question that has puzzled scientists for ages. Darwin thought it was about finding less hairy mates, while others believed it was to keep those pesky lice away. But these days, most researchers think it all comes down to staying cool. Picture this: our ancestors were strutting their stuff on open, dry lands after they learned to walk on 2 legs. Think of a patchy forest or a sunny savanna instead of a lush rainforest. In that kind of environment, overheating was a real threat. So we evolved to have less body hair and more sweat glands to help us cool down by sweating like crazy. Now Titan, the moon of Saturn, is like a treasure chest of resources just waiting to be cracked open. We're talking hydrocarbon reserves that make Earth's look like a kid's play, with petroleum for days. Plus, it's got all sorts of organic compounds like methane, ammonia, and water. And don't forget its atmosphere is a nitrogen party, just like early Earth's. Here's where it gets really interesting. If Titan's atmosphere is similar to what Earth used to be, we could totally transform it into a modern Earth-like atmosphere. Picture this: giant mirrors in space beaming sunlight onto Titan's surface, heating things up and releasing water vapor. Oxygenated atmosphere coming right up. And to top it off, Titan hangs out within Saturn's magnetosphere, so it's shielded from those pesky solar winds. Now Titan's gravity is about 1/7 that of Earth, which could lead to muscle and bone deterioration over time. To counteract that, our bodies would need to develop stronger muscles and denser bones to withstand the lower gravity. Seems like Earth is the only place where we can't skip gym without gravitational consequences. Now, when it comes to being the hottest planet, Mercury may be the Sun's next-door neighbor, but Venus takes the crown. The temperature there is a scorching 870 degrees Fahrenheit on average. It's like trying to survive in a pot of boiling water or in the fiery depths of Venus itself. I guess the richest people out there would be those selling sunscreens and ice cream. Sorry folks, no amount of evolution can turn us into superhumans who can handle Venus's extreme conditions. The only beings that theoretically could possibly thrive there are tardigrades. These tiny cute little critters that look like caterpillars and have some seriously impressive toughness. They can survive boiling water, the darkest depths of the ocean, and even the freezing airless emptiness of space. In fact, they were part of a scientific study on a spacecraft that unfortunately crashed on the moon. Still, recent research proves that even these guys won't survive on Venus. Now, look at this guy. He's been kicking it on Mars for ages, which explains why he's rocking the wrong shade of self-tan. Turns out all those carrot-loving carotenoids in his diet, like sweet potatoes, bell peppers, tomatoes, and pumpkins, are the aces up his sleeve protecting him against UV rays. The more he munches on those, the more he turns into a walking orange. And let me tell you, his strength? It's all about that Martian gravity, my friend. The gravity there messes with our perception of weight. So if you want to be a boss on Mars, you gotta chow down big time. Like, if you weigh 150 pounds on Earth, it feels like you're carrying no more than 55 pounds on Mars. So overindulging in food can totally help bridge that gap between gravity and weight. Ooh, time to feast like a Martian.
Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the Sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit. And at night, it becomes terrifyingly cold, down to negative 290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now it would become much harder to send our spacecraft there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us, Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal, all because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of negative 353 degrees Fahrenheit. Blah! But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about negative 370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. What a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this. But it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.